welcome back to the channel and welcome back to the inventory series, let's say. In this part, we're going to be going over making an inventory in a more Resident Evil style approach, where we'll be making items in a grid, like with a basic inventory, but instead of items only taking up one slot, they'll be able to take up a handful, whatever size you want. We'll be able to determine that late in the project itself for each item, and it's about moving them, rotating them inside of that same inventory. So let's get into it. So as usual, start off with a template. In our case, we'll use the first person, and we'll start by calling it, well, let's say RE inventory underscore inventory and create. If you want to do this with the first or the third person, it's the same thing. There's no real difference. So whatever fits your needs. So go with that. Okay. So once the shaders are loaded, we're going to start off by importing the assets that I made for this. So they'll be in the description below in a Google Drive. And to do that, before importing them, we'll make a folder for them. So the folder we'll make is inventory. And the folder we then want is a folder for the assets. So we'll just call it that, open it up, and I'm going to pull them in from my other screen and drop them here. So they're just pretty much Tetris blocks, which is kind of the points that we have different shapes of grid size without too much difficulty. So I made these really quickly in Photoshop to have it be more visual than the other tutorials. So next I'm going to go through every single asset we're going to need. That way they're all here. We know what we're going to do, and we'll go through them little by little because this can get a bit complicated at times. So I'm going to do my best to make it as clear as possible. So we're going to start off, as with any inventory, we're going to need a data asset. So we'll start with a folder, which we'll call data assets. We're going to have another folder for widgets. And that does it as far as the folders go. So first, let's do the data assets. Let's open that up. And inside of here, we're going to create a blueprint class. It's going to be in all classes, and we're looking for data assets. Now make sure you select the primary one. The basic one won't do anything. Select it, and we will call it DA underscore items. Next, for the data asset to work, we're going to need a structure. So we'll add that in here as well. Inside of the blueprint part, go down to structure, call it ST item. And obviously we're going to be making this later. We're just going to go through everything first. That will do it for the data assets. Later we'll make the different ones, but for now, because there's nothing in here, we can't do that. We'll go to inventory, back to our main folder again, and we will do the different assets here. So, more like actors. So we'll start with a blueprint class of type actor. Call it A underscore item. This is the item that we'll be able to pick up to add to the inventory. Next, we want to make another blueprint class, this time of type actor components, which will be our AC inventory. Next, we want to make our player character. And so instead of taking the default player character, which we could do as well, we'll make a child blueprint of it. So select blueprint class, and we're going to look for first person, and we're looking for first person character. Now, if you're doing this with the third person template, then it's third person instead of first. Select it. We'll call it FPS, and we'll call it character or Cara, just to make it shorter. Next, what we can do to make things easier, because I don't like working on this level because it has the world partition enabled and we can't disable it, we're going to make a new level. So just in the files, new level, basic, and we'll save it inside of our inventory as well, and it will be just new map. New map will do. Next is where we get the new stuff. So this is things that aren't in normal inventories, and that is going to be, we're going to be using a tile map for this. So before making the tile map, we're going to make the tile set, I think it's called. So inside of paper 2D, we're going to look for tile set here. We're going to create that, and we will call it TS underscore occupied. Like that. And next we want, same thing, 2D paper, but we're looking for tile map. And this time we'll call it TL underscore item layout. Layout, sorry, not like that. There we go. Now, the last step, so that we have all our items, or all our actors, and all our widgets and all that, is, well, the widgets. So we'll open that, and we're going to have quite a few in here. First UMG we'll call UMG underscore dropdown. And this is just going to be the options that will be available to the player once he right-clicks on an item. Then we can just duplicate this because it has nothing on it, and it's easier to do that instead of right-clicking every time. And this one will be grid. Next, we're going to have another duplicate. It's going to be called the inventory. Go. Another duplicate, which we will call item. And this is going to be the item itself that we're working with. Then we want to have one last one called slot, which is going to be the empty slots. And finally, this time we need an additional one, which we're going to be calling visibility. And this is going to be used inside of the item itself. So it's not going to be used on its own, but for the item, for detecting where different parts are, as everything is in a grid format. So the first thing we're going to do is we're going to make our items, because once that's done, we won't need to touch them anymore. So we'll just start off with that. And that will include, obviously, explaining what these two are for. But first, we'll do our data asset, because without the data asset, we don't have anything to work with. So open up the data asset, or the data item, DA item, and we're going to start with our variables. Now, as usual, we have a name for our item, because it's pretty useful. Not of type name, sorry, it needs to be of type text. We then need a texture 2D, which is going to be of type texture 2D. Actually, we can make sure you choose this one. We can just call it texture, very simply. Then this time we need to add something called a layer, and the layer is going to be referring to the actual tile map here. So we'll need to set this up once we do that later. So integer here for the layer. We want the max quantity here. As usual, with any item, the max quantity is set in the data asset. We can just put this above. And the last thing we need is the default shape. Now, the default shape is going to be of type 2D, 2D, and we're looking for vector 2D. And it's of type array, because we need to make sure that we can have multiple points. This is going to be how we're going to display what shape the item is in the program, or at least in the blueprints. That's how we're going to do it, so that it knows what size it is inside of the actual inventory itself and what slots in the inventory are occupied and which are not. Unlike normal items, we're going to need to add some functions this time. The first function we'll call is getShape. Next one is rotateItem. We then need getMaxSize. And finally, one last one, which we will call determineShape. Now we're going to go through and make these now, because then we don't have to touch our item or our data asset item anymore. So we'll start with getShape. So for getShape, the first thing we need is we need an input of type rotation. So this is going to be a float, and we'll call it rotation. And in this case, we can actually make it pure as well. And the output we need is going to be of type default shapes. What we'll do to make this easier, we'll put a return, and we will drag our default shape right here. So in addition, for the return, we're actually going to need a default shape here. What we're going to do is, if this is equal to 0, so if it's different on true, on false, it's going to be equal, meaning we can use the default shape because the rotation is 0. Now on false and on true, on the other hand, we're going to have to do a bit more than that. We're going to have to actually rotate the shape. So we're going to get a reference to our default shape again, because that's going to be the base form that we have for the shape, and we're going to adapt it according to that. So we're going to get a for each loop. And with the for each loop, what we want to do with the for each loop is we're going to get rotated 2D, and the angle we're going to use is our input rotation. So we can get a reference to that by searching for it. And with this, we're going to need to reroute it a bit, and we're going to need to duplicate this, let's say. So we're going to grab another reference to our default shape and promote it to a local variable, which we'll call return shape. Now we can get rid of both of these. Now what we'll do is we will add return shape. We'll add our output here to return shape. Let me just grab that here and realign that here. Now, normally this would be enough, but I'm not sure. Well, the reason is mainly because how this rotates is it will rotate the item outside of 0, 0. So let's say we have an bar that says it is in location 0, 1, 0, 0, 1, 0, 2, 0, and 3, 0. So it's just a straight line, pretty much like our assets right here. If we rotate it using this function right here, what will happen is it will appear outside here, and it will result in it being negative, which isn't correct because that will mean it's outside of what we actually want visually. So we can't just stop here. We actually need to tell it how far off it's going so that it can adapt it and push it back in, let's say. So to do that, we're going to add a sequence after here. And close that, don't need it. And in the sequence, what we're going to do is we're going to actually break the 2D vector here. And with the broken 2D vector, what we'll do is we're going to check whether this is superior. We're going to check whether it is inferior. And what we're going to use here is a different value or a local variable, which we're going to be calling smallest x. So list x. Now what this will do pretty much is it's going to check how low the value gets, and it's going to move the different pieces accordingly. So we can then get this, and we want to save it here if it's true, and we're going to promote the x to that same value. That way, if we find something smaller, we'll keep promoting it down. Now on the second sequence, we'll do the exact same thing, but we'll need a y instead. So we'll just reroute all of these. It'll work just the same. We're just going to need to duplicate our variable and replace them here by going right click and refine or replace variable with the new one. So now what we need to do is we're finished with this. This will go through the loop and give us the values that we need, but we need to go through it one last time, or we need to go through our new loop now another time and say for each, and we need to update all these now. So what we'll do is we will say from here, get a reference to our return shape, set array element to the index that we have here, and the item will have to be this, so our array element minus the smallest x and the smallest y, which we will plug in here because they are automatically by default set to 0 here. And because they're set to 0, any value lower than them is obviously negative. So because we want to offset them back in the positive way, we just subtract the negative, meaning minus by minus is plus. So we'll be adding them, and we attach that into item, and that will fix the issue of the offset due to the rotation. Let's line those up. And on completed, we do return node and plug in our return shape. Okay, so actually we don't need rotate item. I just checked and we don't actually need it because it's not used. Get max size is the next one. So get max size is going to return pretty much the input, or more like the output of get shape, and how large it is as far as columns and rows go, because that's how things are used inside of the widgets. So that's what we're going to get here, so that we know how to size our widget in our grid. So the inputs it needs is a rotation, once again, rotation. And the second one we also want is, we'll call it default override. And this is just to say that we want to get the default one, doesn't matter what the rotation is. So to do that, what we want is we will get our shape here with the rotation, and we'll use a select node. And with the select node, we're going to get the default override. And if it is default override, then we get our default shape here, and we use that instead. So let's just line these two up. And we want to plug this all into a for each loop. Now in the for each loop this time, what we're looking for is the highest values on the x and the y. So what we want to do is similar to what we did in the get shape. We're going to have a sequence, we're going to check whether our x is superior to a certain value. And sorry, no, sorry. So we'll do the same thing as before, do inferior. And what we'll do is this. So what we're going to be checking is if this value here that we're going to make, which is going to be L max underscore x, so we can see the difference. And if this is true, then that means that the value we're currently looking at is bigger than the maximum. So we want to set it here to the new x. So let's reroute here. We can copy this once again, and this time we'll have to duplicate and replace it with y as well. And we'll just drag them on top of each other to change the reference. Let's just add another reroute here and move this a bit to the side. Now the final thing we need to do is the return. So in this case, the return is going to be an integer. So we need to convert these over. The first return is going to be the column, and the second one is going to be the row. It's going to be both integers, as I just said. So we get max and we get the two maxes, and we want to add one because given how this works, these are coordinates, and coordinates start at 0, whereas the span of the grid slots work from 1 to, well, the distance that you need. So we need to add 1 for both of these every time. And once we've done that, we can truncate them by just connecting them directly. So let's just align these up, compile and save. And I think this one can also be, no, so we want to keep this one as an actual unpure because we're going to need the execute pin, so it's only called once. Finally, we have determine shape. So determine shape is what's actually going to tell our default shape what it needs to look like. So this one's going to be called once, pretty much. It should only be called once because information is saved inside of the data assets. So there's no point in calling it all the time. So what we do is we clear, because if there is already a version, we still want to get rid of it just in case it gets called multiple times. And we need a reference. Now, the reference we need because we can't do what we want to do here, whereas it's going to be getting a reference to our tile map here. We can't do that without an actual component for that. So it can only be done at runtime, so that's why it can be called multiple times, and we need to be careful of that, because it's just a waste of resources. So what we want to get is a reference to that exact component. So this is going to be the tile map, and we're looking for tile map components. And it should be paper tile map component. And with that, what we're going to do is we're going to call our tile map here, and we're going to say get map size. And so to get map size, what we'll do, so we're going to go through both of these with a for loop. And what that'll do is it will tell us pretty much line by line and column by column what the actual paint of that, let's say, tile map is. And so we're going to be setting that up later, but we're going to read through it now. So because once again, this is a width and we need to convert it to an actual for loop, we need to say -1. And we're going to then plug this into a for loop. So the for loop obviously goes to the last index, and we're going to promote this to map x. So map x, because the width is what we'll use for the x and the height will be the y. So we're going to add a reroute here, and we're going to say -1 again. And this time we'll also add another for each loop, for loop, sorry, not for each. And we're going to plug the last index into the -1, duplicate the x and call it y, replace the 2. And finally, now is where we actually determine whether we need to take this information into account. So to do that, once again, we need a reference to our tile map. And inside of the tile map, we can say get tile. This is going to get a direct reference to a specific tile inside of the map. So we put in our x and y, and the layer is the actual variable layer that we have right here. So we can align those up. And what this does is it has a structure here, which we're going to break. And the only information we want is the actual set, because this is what it's going to actually look like, what the texture, let's say, is. And so we double equal it, and what we'll set it to is we're looking for our tile set underscore occupied that we made right here. And if it is equal to that, then well, that means it's occupied. That means that there's something there, and that's the actual item itself. So if that happens, we get a reference to our default shape, and we say add the actual, well, location. And the location is our map X and our map Y, which will now be converted back to floats right here. Or converted to floats because we haven't done that before in this blueprint. And that should do it for, and that, sorry, not should, that does it for our actual item itself. So we can now close all three of these and close our data asset. So to finish things off with our data asset, what we'll do is we will go and actually make our structure as well while we're at it. So for the structure, very similar to what we did before in our other tutorial on just a basic inventory, we have data assets for the actual reference to the object itself. So DA underscore item, make sure it's an object reference. Then we want the rotation this time, because the rotation is something we need to take into account given that it can be a shape. So we need to know which way it's oriented. And finally, we need to know how much we have. So quantity, which is going to be an integer. So close that now. And the next thing on the list is going to be the actual, well, our tile maps. So to do those, we have the two things here that we want to open. First, we have the tile set, and then we have the tile map. Now, I'm not very well versed in anything that's paper, especially 2D and Unreal. It's not at all what I touch, but this is how I decided to do it, and it works surprisingly well. So just follow along, there's not much to do here. We just want to set the tile size to 1 by 1. We want to change the sheet texture here. This is mainly visual, it doesn't change much. I used white square texture here. Any one is okay, any texture works. It's just whatever you prefer. And it will create this texture here. That's what it will do. It will add a tiny point in the top left. If we make this bigger, then it becomes bigger as well, I think. But in our case, we're just going to keep it 1 by 1, which should give us that result. And that's all we need to do. We can then close this, save and close. And most of the stuff is going to be inside of our item layout. So the first thing we need to do in our item layout is we need to tell it what the tile set is. So to tell it what that is, we need to grab it from our content browser and drop it in our tile set selector. Then we want to tell it that we're selecting this, and then we'll be able to paint. Now, before we start painting, we need to do a few little things. So the first thing we want to do is we want to change our tile width from 1 or from 32 to 1. And we want to change the width. So in our case, we can leave it as 4, but you can make it bigger if that is what you want. So everything here is good. The reason this is so big is because when we select all of this, we're selecting 32 by 32 because that's the actual size we saved here, or is saved here at least. I don't think we can make this any smaller. Yeah, so because it's a float, we can't make it any smaller. So what we simply have to do is we just go and select a tiny pixel here, which is just 1 by 1 because we're zoomed 32 here. And now it's actually 1 by 1. So this will be our actual appearance. So to allow that to work, we now just need to go through our list and actually make our different items. So we'll do that in here first, and then we will reference, or we'll do that in here first, and then we'll say which layers when we make the actual items themselves. So let's go ahead and do that. So the first one, I'll only make 2. Obviously, if you want to test with some more, you can do that. So we'll start with the I block, and that's going to be the simple 4 points like that. So a straight line, nothing too difficult. And then what we'll do is we will make a second one, which we'll add right here, and we will call this the J block. Now, obviously, we can currently see the whole thing from before. That's because we have multiple layers, so we can just hide the I block and only see the J one, and the J will simply be, well, these 4 points like this. So that does it for the items. It's as simple as that. That's all we have to do. In addition, we can also disable the collision because we're not going to be using the invert in Unreal 1, I guess. Like, we have a warning here, but we're not actually going to use it, so just disable it down here. Save that, close, and now we just need to go and create our actual assets themselves. So right click in our data asset area, and we're going to look for data assets. and base it on our DA items. Select, and we'll say DA, and we will say I block, because that's the one that we made. And we also will go ahead and open it. We'll call it I block. It's going to be the block, just will get us all of them. We want I block, and for the I block, the layer will be 0 because it does it from the top down. So that means that the J will be number 1. So max quantity we will put at, let's say 10. And as you can see, the default shape is currently empty, but we'll be setting that up in a second. So duplicate our I block, we'll just replace it with a J. And we will then change the icon from I to J, change the letter at the front here as well. And quantity will leave the same, and everything is done now. We need to change the layer to 1, otherwise it won't work. So we can go and close both of these, we won't be needing them anymore. Next up, we actually need to change our world settings so we can actually see our player and all that. So first we'll add a start so that we know where the player will spawn. Then in the world settings, we're going to add our first person game mode, but we're going to be changing the default pawn class to our FPS Kara, which is the one we made right here. And to make it work, we need to add our AC underscore inventory. And now we no longer need the player anymore. So if we play now, we should have the first person character. Yep, we see the arms. And we can go and open our AC inventory for now. That's where we'll start this all. Okay, so let's start off with our typical inventory stuff. So the first thing is we need some variables. The variable will be first, we're going to need a reference to our UMG inventory, as that's going to be what we're opening. So search for UMG inventory as type. Then we're going to want the actual inventory itself, which is going to be this time, unlike before, we're going to be using a map as well. But for the key, we're actually going to be using the 2D vector. So we're going to set this to map, and for the value, we'll be using the ST item that we made, so the actual structure for our item. So make sure you have vector2 as the key, otherwise, because they do look exactly the same, you wouldn't be able to tell the difference, so just make sure you have the vector here. Next, we're going to need another one, which we're going to be calling inventory state, and we're going to be using this here, but we're also going to have a copy of one inside of our grid, inside of our grid. And so it's going to take a vector2 again, but unlike for the inventory, this one is going to have a boolean, because we're going to be using it to check whether an item is, or more like a slot is occupied, instead of every time we need to check, going through our inventory list, checking that it is available. That way it's always stored and will be updated as the inventory gets updated as well. Next, we need to know how big our inventory is. So we're going to get inventory size, and that's just going to be a simple integer. So there. And we'll also have inventory width, which will do the same thing. Inventory size will be how many slots. Inventory width will be how wide the inventory is. So 34 is usually what I go for the inventory size, and 10 for the width. That way we have not a perfect square, but we have some offsets so we can test stretching and whether the object will go outside of the grid if it can. So in event graph, we're going to need to set up a few things. So as far as inputs go, we're not going to make an input mapping context here, because all we need is the actual tab key for actually opening the inventory, and that's all. We don't need anything else, so we won't bother with making an actual IA action, etc. So we're going to need some functions here, as most blueprints kind of do. The first one is going to be called here, and it's going to be called default inventory state. And what it's going to do is it's going to run through the size, and it's going to set our inventory state. And then later we'll modify if we already have something in inventory to let it know. So we'll compile that. I'm just going to add all the functions first, and then we'll go through them one by one. So once we have inventory state, we want to have some basic functions that will add and remove from state. So the first one is add to state. The second one is remove from state. And we'll put this in a category we'll call state, very simply, because that's all they do. That's all these functions ever do. Next, we're going to have something very similar, which is going to be more inventory oriented. So we'll say add to inventory, and we're going to have remove from inventory. So both of these can go in a category we'll call inventory as well. Let's go there. There we go. Next up, some functions that we'll use for conditions. One is not fully stacked, which is going to check if an item or if a slot has extra space in it, like we did in the previous tutorial, or you would have in any case of any inventory. So this is going to be in a category we'll call conditions, and it's going to have another one next to it, which is called ShapeFits. So ShapeFits, same thing, it's going to go there, and what it will do is it will run through this and tell us, well, hey, is there enough space to put this new item we're trying to add in this location? Finally, we're going to need a pickup item. And this one is going to be rather small because it's just going to be used to tell whether the actual item, it's going to be called from within the item to say that we're picking it up, but we're going to have another one which is going to call add item to floor or from floor, which is going to add now, which is going to be used to perform most of the calculations for this, as I found it at least easier to do it this way because we only use this in this specific case, and it's just much easier to have it in a specific function for itself. Then we want a last one, which is called drop item, which we've done many times before, which will just place the item on the floor. This is going to be called in a category we'll call manage, because that's what it does. It manages the different scenarios that we can perform. So let's go through these different items. We'll start with the default inventory state. And so pretty much for this one, very simply, we want to get our inventory size. We want to say -1, and we're going to run a for each loop. So not a for each loop, a for loop, and make sure you connect it to last index, and there we go. So inside of here, what we want to do very simply is we're going to need 2 local variables. If I'm correct, I think it's just 2. Yeah, so we want 2 local variables. One we'll call grid X, and it's going to be of type float, and another one we'll call grid Y. And this is simply going to be used right here straight away. We're going to say add, plug this into loop body, and we will split this here, our key, and it's going to be grid X and grid Y. Sorry, don't drop it on top, drop it next to it. And we can line these up. And we're going to leave this false because that means that there is nothing in the inventory at this location. Then what we want to do is we will say with grid X, what we'll say is if it is double equal to our width here, -1, and we have to use -1 because once again this is an index and this is a amount, let's say. So we plug that in, and if this is true, then that means that we've reached the end and we need to cycle back to the beginning of the line, but on a row below. So to do that, we simply say if this is false, we increment our grid X, and this will mean if we were on, for instance, let's say 7 of line 0, then it will become 8 of line 0, then 9, then 10. Well, no, we'll stop at 9 because, well, 9 being index 10 in essence, or the amount 10. Then we'll cycle back around here by saying grid X to 0, and we will say this, we'll copy this and we'll just replace it with the Y. After this is very simple. We're going to loop through because in a case where we have a test here, we want to have an item already here. So we're going to say, well, we'll put item I, let's say, no rotation, and we'll say there's 5 of them. This will only do the default state, but we need to tell it, well, hey, we have some more coming in. We do already have an item, so we need to inform it that we already have that item. So to do that, we go here and we say get our keys from the inventory. And with the keys, we'll do a for each loop. And once again, get another copy to inventory, and we'll say find. And we're looking for specifically the actual structure that we have here at these coordinates. And obviously, if this is empty, it's just going to immediately go to completed, so it won't bother. We can then break this, and normally if the key exists, it will always find it, so we don't need to bother with the branch here. And what we'll do is we're going to say break, not break, we're going to look for get shape here. And because we know now what the rotation is, it will tell us exactly, oh, sorry, we don't need to open that. We will be able to know relatively the exact shape it has. So what you do here is you plug this into another for each loop. And this for each loop, we will be telling it, well, to modify this right here and making it positive. So we can actually change this and recombine it. Now, one thing to note is we can't just plug this immediately here, because the result we're getting out of here is relative to, well, itself. So if it's 0, 0, it's 0, 0, even though the item may be in 5, 0 as far as coordinates go. So to avoid that, we need to make sure that we go here and tell it to add the result of this array to the array that we found it in, which is its coordinates pretty much. And this time we want to make it positive because something is occupying that space. And that will do it for our default inventory state. Next, we can just go ahead and say, actually, I don't think we need to do this way. We could also alternatively, yeah, so instead of this, what we'll do actually, because I didn't do this in my version, we can actually collapse this to the actual, we won't collapse it. We'll copy this, and inside of add state, we're going to actually plug all this in, because that's what it's actually for. The whole point of add state is for this. So this will get us the structure, and this will get us the location. So we'll call it like this. And we could invert these. Yeah, we'll just invert them. That way we just have this here. And we'll just call our location like this. And so also what we can do, obviously, we can just do the same thing, but for remove. And so for remove, we'll just actually delete this, duplicate add, and we'll say remove from state. And instead of being true, we put it false. And so inside of our default here, instead of doing what we did before, we say add state. We simply need to plug in our structure and the actual coordinates, and we're done. This will do the trick for us. Let's just realign that. There we go. So we can compile. We can close the default. We've just automatically did this one as well. And we can move on to the add to inventory. So add to inventory is pretty simple. We get a reference to our inventory here. We say add, and the information we need, well, we're going to get it right from here. So we'll just plug this in. Key and value will do. We'll just get a reference to them like this. Get key and get value. You can align these up. And what we'll do is we'll also add a Boolean here to check whether we want to change the state, because in some scenarios we don't want to. So we'll say modify state. And if modify state is true, so we'll call it here, we will tell it to actually ignore what we're going to add after, which is going to be calling the add to state. Now add to state, should be on false. It should be on true. If we want it to happen, we'll modify the state. So we can just copy our key and value here, key being location, value being structure. And obviously you can't mix these two up because here it won't let you plug it in. For remove from inventory, we don't actually need as much information because we just need to know the key. So in this case, we will have two variables. One we will once again say modify state, and the other one which will be the actual key. So the key is of type 2D vector. And we'll start with a sequence here this time because we need to modify it first. We can't modify it unless we actually still have it. So we can't call our remove here without having actually modified the key. So without having modified the state first. So we have to do this as a sequence, or we could also do it with reroutes. It works as well. So once again, we want to get modify state, add a branch. If it's true, we're going to say remove state. And this time, because we don't have the actual key, we don't really need it. We can say for location, we want to get key. And for the structure, we can say from inventory, find the actual key itself. And normally if we can call the remove, that means that the key exists. And if the key exists, then there's some value somewhere with that key. Otherwise it wouldn't work. That does it for the add and remove inventory. Next, we're going to perform the is not fully stacked and the other condition. So is not fully stacked is pretty simple. Taking a structure, check whether max quantity is equal to the current quantity. If it's not, then we're not at max stack and we'll let it know. So for this one, we can have a pure, and input is going to be our structure. So we'll call it that, item structure. And it's going to be type st item. And the return this time will be return value, will be of type boolean, and it will be of type integer, so we know how many is remaining. So that's what we'll call it, remaining, and it will be an integer. And so to do this, we will break our structure. We will get from our data asset our max quantity, line these up, and we want to check whether our quantity is superior, or like we'll check if the quantity is inferior, and that means that we have something remaining. So let's just realign that. If it's true, then there's something remaining. And so to check whether what that quantity remaining is, we'll just subtract from the max quantity the current quantity and plug that into the remaining. We can also just hide the rotation here by hiding unconnected, and it will line up a bit nicer. So make sure this is pure. It doesn't have to be, but it's better in most cases if it is. It's easier to use, especially for conditions. Next is the shape fit. And shape fit is pretty much just going to loop through the array, or our map, to see if there's enough space for it. So if the input is actually going to take the shape, so we'll say shape here, and it's going to be of type 2D vector, not box, 2D vector, and it's going to be an array. And what we'll need first is we need to actually go through our inventory state here. So we will get our keys, and we're simply going to search in those keys whether we can find our shape. Okay, so what this does in more detail is it doesn't just check whether the slot's available. It will go through this entire loop here, and it will check whether we can fit, where we can fit the item is probably a better way to put this than actually shape fits. So let me just see if we can actually rename that. So we're going to change this one to a pure, and we'll say where shape fits, more like it's more adapted to what it is, as the return value will be one whether we can fit it. So that's going to be a boolean, and the other return is going to be a valid actually key saying that, hey, it can spawn at this specific location. So on completed, that means we failed. That means there's nowhere to fit it, so we don't bother. On the other hand, if it does fit, we're going to, or more like in the loop body, we're going to do a find and check here. And what we're going to look for is, because we know we'll always find it, we only want to take the top one here. Make sure you use the top one. And we're going to put it into a branch. And what this branch will do is it will check whether it is negative, and if it is false, that means there is nothing currently sitting there. So that will be referring to, as a new variable, we'll be calling the, L empty slot. So this is the extra space we currently have available, and it goes into false, because if it's on true, then that means it's a slot currently occupied. So with that in mind, we now actually get to go and get our shape, and we can run through the shape and see if from this position it can actually be fully placed, if there's nothing in the way, no obstacles. So to do that, we will say plus right here, and we're going to add our empty slot, because empty slot is the actual place in the grid, whereas this is just local space. So we want to get another reference to our inventory state here, and we're going to say find. Now, unlike before, in this case where we know we're looking specifically for items inside of this actual map, we don't have to check for this, but now we actually do. Because in this case, if the item were to, let's say, be on the edge in, let's say, 90, meaning it's at the last column of the first row. If the item actually extends to the right, well, it's not going to actually find these because it's outside of its actual keys. It's outside of them. So we need to check whether that actually exists or not. So what we'll do here is we'll add a not boolean, and we'll use this to say, well, if it's not, or if this is true, meaning that if we do not find it, it becomes positive. So if we do not find it, or if we do find it and it's positive, then that means that we want to stop. That means that this position isn't possible. We can't keep going with these values. So in that case, we're going to actually add a new value here, or a new variable, which we'll be calling failed. And the reason we do this actually is because I made another mistake. This shouldn't be a for each loop. It should be a for each loop with break, because we need to actually break this if this fails. So let's plug this all back into the branch. And if it fails, we need to put a boolean. Sorry, it should be a boolean. We will say true right here. Now, the reason this is because when we break a loop, it actually still goes around and does the completed. So we need to be able to tell the difference from a successful loop and a failed one. So to do that, we simply have our failed condition here. So to confirm whether it failed or what to do when it failed, if it failed, so true, we want to set it back to false and do nothing. And this will send us back right to here, where we'll go through the loop again and try a new empty slot. On the other hand, on false, we're going to call here on false, we will get our empty slot and we will return that it is true that we managed to find this place where it does fit, and we will simply return the valid key where we attempted to fit it. And that'll do it for our WhereShapeFits. Now, the next item we have on our list, or the next function we have on our list of things to do, is the pickup item. Now, the pickup item is rather simple, but it's going to be leading to something a bit more complicated. So for the inputs, we want the item itself. We want to get the item reference. Now, the item reference itself currently doesn't have the information we need, but we do have it, and we will just set it up because the only thing we need is actually structure, which we already have, so we'll manage that right now. So from here, we want to call add item from floor, and item from floor has the item structure, and it also has the actual return for success, and it also has a return for the quantity remaining. And so the quantity remaining is going to be an integer. This is going to get, item structure is supposed to be the actual structure of the item. Make sure you set that here. Let's plug this in there. And what we'll do is here we'll have a branch, and the branch actually uses the remaining. Now, if remaining is equal to 0, that means that we have the whole item added to the inventory, so we can return here that this was successful. So we'll put a return value here, and we will say that it succeeded in removing everything. Now, if it did not succeed, then we actually need to modify the quantity. And now we don't have that function set up yet either. It's going to be from item ref, and we're going to say modify quantity. We'll do the item first because it quite literally takes like 10 seconds. So open up the item, and inside of the item, we'll just make our functions. We won't bother with anything else. We have modify quantity, which is simply going to take an integer in, which is quantity. It's going to be an int, and we just need to add our actual item structure here. And that's going to be of type st item. And in this case, we want the st item to be instance editable, or you can just click on the eye icon right there. So save, close the item for now. We'll come back to it in a second. Here we can now say modify quantity, plug that into the return, and the quantity we'll be using is the remaining. And from here, we can now get our item structure, which we will plug into our add item to floor. Okay, so inside of our add item from floor, let's just close all of these because I don't need them anymore. Inside of add item from floor, we're going to start off by moving that to the side. We're going to move this here and promote it to a variable because it's easier to access. Item structure, we'll call it. Not like that. Try and write it correctly. And we're going to start off with a sequence. Now, the whole point of this sequence is so that if we'll check first if we actually already have an item of the same type that has some free space, we will add it to that item. We'll just stack it on top, right? That's what we'll do here. And on success, we will use the return node to actually not call the second one. And on the other hand, the second node here will be to go through it and say, well, hey, this item does need to have a new slot. Where can we place it? So we'll start with our keys right here, and we will go through the actual loop looking for whether we can find an identical item. So we will, I think we can promote this here because we're going to need it a bit later. Otherwise it gets a bit messy, yeah. So we'll promote this to a variable we'll call L loop, I think it's, yeah, loop key. And we're going to have another one we'll call loop value in a second, which we will do by find item. And we need a reference to our inventory again. Let's just get both of these, align them up. Promote this to another local variable called loop value and plug this in right here. Next, what we want to do is we'll add a branch, and this branch is going to check whether our item structure and our loop value are the same. Now we can't directly do that, so we need to break both of these and check whether their data assets are equal. So then we can hide the unconnected, align these up, and plug this in to our actual condition itself. So on true, that means the condition does exist, that the item does exist, that we do have one that is identical that we're trying to add. So we want another branch that just checks whether, well, there's enough space, and that's our function is not fully stacked, which we have right here, which will take in our loop value right there. And so if this returns true, then that means that we do have enough space. If it returns false, we just go back to our beginning of the loop and get a new key. So on true, what we want to do is we will say add to inventory, and we'll be adding our loop key. And this time we specifically do not want to modify our state because we're adding to the old one. So we don't want to modify the state because the item didn't exist in our inventory prior, and there's no reason to actually do that. So here what we'll do then is we have our remaining. We're going to reroute it here, and we're going to plug it in, sorry. Yeah, so what we'll do here is the remainder will be used to actually subtract from the current quantity here. So let me just get our item structure. And we're going to say this time, instead of our data asset, we want a quantity. We're going to say quantity minus remaining is what we have left. And that will be used to update the actual item structure here. So we will say set members in structure, and we're going to set the quantity. And for the quantity, what we want here is we want another branch, and we're going to say if it's empty, well, we succeeded and there's nothing left to actually remove. So we'll break this, just get our quantity and say if you're inferior or equal to 0, then we succeeded, so return, and we'll say success, remaining 0. Just hide these, we just want the last one. But before that, we do still need to modify our other things, so let's just finish that up right here. So now we need to actually set the value. So to do that, we'll say a make here, structure. And we can start off with our actual loop value, because by default it's going to be the same. So we can break this here, plug in the rotation, plug in the data asset, that will be the same. What will change is the actual quantity. So we're going to add the actual quantity we have here directly to it. Now this may seem strange because we have a remaining, etc., but simply what we need to do here either way is we're going to add these together, and we're simply going to clamp the actual integer, because either way, no matter what quantity we add, we just need to clamp it to our actual max quantity, which we can get from our data asset, which goes into the max, meaning the quantity will never go over our actual maximum that we have. So we can just align this. We'll move this a bit to the sides so it's more readable. And that will do the trick for updating our actual inventory if we already have an item that fills these conditions. Now, on the other hand, once the loop is done, we don't want to stop anything. We want to actually test whether there's another space available. If there's more inventory slots available, then we can actually add it directly there. So to do that, what we'll do is, I originally did this in 4 parts, which is very messy, so we're not going to be doing that. We'll make it once, then we'll convert it to an actual function, which I probably should have done in my case. So the first thing we want to do is we want to break the item. So one thing we could do here, I originally did do this in my showcase, but if we add an item, we want to check whether the item fits in any direction. So we need to check for each of its rotations of the shape and not just the first one. So that's why in my case I did this 4 times when I should have just made a function out of it. It's a bit stupid on my part. So what I want to do here is we want to say get shape. And we don't want to actually plug in the rotation here because we want to test it with every single rotation. So we'll hide these and we will add a reroute here. And so that reroute is going to be used across. And what we'll do here is we will say, does the shape actually fit? Where does it fit? And if it does, well, we can actually say add item to inventory. So add to inventory. There we go. And so if it does fit, we get the key right here. And the value, we're going to make it right here. And the value is going to be made up of our same structure right here, which I'm actually going to have to modify like this so that when we collapse it to a function, it doesn't get in the way. So we're going to break this, and the information is it's going to put the data structure, the data asset, sorry, it's going to put the quantity, but for the rotation, we need to use our actual custom one we put here. And obviously this is also going to return that we succeeded and that there's no quantity remaining. But in this case, we need to modify the state, sorry, so make sure you check that. Now, all of this can be collapsed to a function. Make sure you select this as well, sorry. So let's just go all of here. We want to make sure we select just these. We will collapse to function, and we'll call this check rotation fit. And so we'll put this in our actual, let's say our manage, we'll put it in our manage. And so with this, we're going to be calling it 4 times. And each time we'll be plugging it into our return. So we'll put 4 sequences here, 3, 4, or 1 sequence, but 4 pins. And we can detach this. And this will be the rotation. And the input will be the structure. So we're going to align this, and we'll use this 4 times. Once, sorry, let's just, why is that not aligned correctly? There we go. Once for rotation at 0. Another one for rotation at 90 degrees. And that's all we have to change. We just need to change the rotation. And let's just move this a bit further because there's a bit more space. And the final one will be at rotation of -90. And this one will be at 180. So we don't need to change anything else. This will work just fine. We'll do it this way. It's a bit easier to read then. There we go. So then we want one last one. And this is going to be, well, if it fails, we want to return that, well, this is the quantity remaining. So we get item structure, we break, and we get the quantity. And we can hide the unconnected pins. So just to make sure everything's okay here, we go through our loop, we add the item if it is available. If there is a slot identical, sorry, and it's not fully stacked, we add it to that actual slot. And if the quantity remaining ever becomes 0, because we need to update the item quantity we have in, then if it becomes 0, we tell it while there's 0 left, so we can inform that on the outside with our function item pickup. Comes out here. And after that, if all that fails, so meaning we didn't manage to get it empty, we come down here and test every rotation to see if at 0 degrees it works, if at 90 it works, if at 180 it works, or if at -90 it works. And if all of these still fail, then we return how much quantity is remaining, and we leave that in the actual item on the floor. So we can check if this is working correctly. Let's just try and reorganize this a bit. So we just realign this like that, and the rest of it is pretty okay. We can just get structure here directly. Just plug it in like that. Same for the rotation. Just do that, make it a bit more readable. Get rotation. Go plug this in there as well. And make sure you plug it in here as well. Get rotation. And there we go. And that will make this. And with that, everything should work. So let's just... Actually, no, there's still one last function left we have to do. And we have to do the event graph. So we want to now do drop item. And drop item is a simple function that just drops the item actually on the floor. That's all. So I just remembered something in the actual item. We need to change that first. In the item, we just need to make sure that this is exposed on spawn. There we go. That's all. So we'll leave it open because we'll be modifying it in a second. What we want is we will say get actor, or get owner component, sorry. Owner from the target is actor component. For the inputs, we need to know what we're dropping. So we will get the structure. It's going to be st_item. Go. And so we'll say get actor location. We will say get actor forward vector. And we'll multiply this by, let's say, something like 600, because otherwise we'll be colliding with it and it will immediately pick it back up again. So 600. We will add. Let's just go and align those. And so this will be our start. So we'll say line trace by channel. This will be our actual start. And for the end, what we'll do is we will say this minus 500 on the Z, so we will be targeting downwards. Plug this into the end, and that should do it. What we'll do is we'll say on branch, if we hit something, we do something. If not, we don't. We break the hit, we get to the actual impact point. And actually, sorry, first we need to say spawn actor from class, and it will be of type A item, A_item, sorry. And we have an item structure here, which is our structure that we made. And we'll just have to split the transform to actually get the actor location to the impact point. And then compile and save. And to finish, we need to do the event graph. Oh, actually, I completely forgot. We also need to call our default inventory in the event graph as well. Otherwise, we're never going to set up our inventory. So for tab, which is going to be our actual inventory appearing, we need to check whether our UMG already exists. So convert to validated. If it does, we want to remove from parent. If not, so if it is, then we need to also set it to empty. And we also need to modify the actual cursor itself. So we'll say get player controller. And we will say show mouse, no, not get, we want to show mouse cursor set. There we go. And we will say set input mode game only. Go. So this is for restarting once we're done with the inventory. On the other hand, if it doesn't exist, then we need to create it. So what we'll do is we will say create widgets. We will say UMG, inventory. Plug this in, and we will promote this to our variable. Sorry. We will add it to the viewport. We can then copy this at least, because that's what we're going to be using for making it visible. And then we will say set game and UI, and simply just reroute here so that it's more readable. And that is all we will have to do in here, I believe. Yes. So we will just need to set up some actual inputs right here, but for now we don't have them. So first we'll finish our item, and then we'll move on to the actual widget itself. So compile and save. We can go to the item now. and make our small modifications because there's not that much to do. So the first thing we want is we will be adding a sphere collider, so a sphere collision. And we will be setting it to something like, I think 100 is pretty good. Yeah, it's not too big, not too small. And next we'll be adding a text, this time a text renderer, because unlike before, we don't have a static mesh. Make sure you actually attach it to the scene, not to the actual sphere. So for the text, we will just center it directly. It's easy to use that way. And we'll make it go a bit above, because currently it's just sitting on the floor. Just put it a bit above that. We'll also make our sphere collision actually visible by removing the hidden in game right here. For the text, what we'll want to do is inside of the construct script, we will be getting a reference to our item structure. We will break it, and we will get from our data structure the actual name itself. And then from our text render, we will say set text to the actual value itself. So just like that, align it up. Go, and we can also just hide unconnected pins here. So that will make sure that our text is what we set it to be. So in our case, we don't have them by default. So let's just set it to L block. So we'll know and write that right there. In the event graph, we only need to touch one thing, and that is the event tick. And obviously we're going to need to tell it what to do when we overlap. But for the event tick, what we need to do is we need to tell it to set this to focus. Now, well, we don't have to do this, but it's just that we know what we're looking at. So get world location for our actual text renderer. We then want to get player camera manager, and we'll do the same thing, sorry. We'll get actor location this time because it's considered an actor. And we will say find look at rotation. And make sure you put the world location from the text renderer to start and target to the manager. We then want to get text renderer, and we'll say set world rotation to our return value. And so just to give you an idea of what this does is it will just make it so that it is always looking at the player. So let's just add one in front of us, for instance, and we will see that if we walk around it, it keeps focusing the player. If we jump, it looks up as well, and so on. That's the whole point of this, is that we can just keep reading it no matter what direction we're in. Last thing we need to do here is our sphere. We need to say, well, what happens if we overlap? So on begin overlap, we'll get our actor here, or the actor, and we'll say get component by class. And what we're looking for is we're looking for our AC underscore inventory. And if it is valid, then that means we found it and we're talking to an actor that can contain the inventory. And so we're going to say pick up item. The reference is obviously going to be self here. So get a reference to that. And on the return value, if it is true, that means this item's been completely consumed. So we're going to say destroy actor. And all that's left to do now is modify quantity, which we can just do really simply is we take in our structure, we say modify, set members, and we will set the quantity to the quantity in, and we can just compile this, save it, and close it. We don't need it anymore. And let's see what happens if we walk over it. We pick it up. So just to see if this is working correctly, we'll make our inventory visible here. And because we already have an I, and I think the maximum is 10. So currently right now, this item has 0 in quantity, I think. Yeah. So if we put 2 here, we'll press play, we will pick it up, press F8, we can go and select our player character, go down to our components, and in inventory we have one item because it's the same item, and we have quantity of 7. Let's see what happens if we put this as a quantity of 7 directly, meaning it's 5 plus 7, which is 12, which is more than what we can contain. So we should have 10 and 2. So let's go and check if that works correctly. If we're going to AC inventory, we have 2, but we don't have the actual 10, so it got rid of the old one. So I'll try and figure out why that is. Oh, okay, I know why. So the reason is inside of check rotation fits, because I originally had it as an actual individual thing and not a function, the issue is it's always returning a success even if it fails to actually place it. So what we need to add here is a return node and a condition. So we need to let it know that it failed. So we need to say success here, and on the add inventory it's true, but here it's false. So we can close that, and inside of our add item floor it will look like this now, and we can just we can't plug that in directly because if it fails it might succeed here, so we need to actually have a branch which says on success we can actually do that. So let me just delete these, it'll be easier to just copy paste. There we go. Let's just align these all up. And now normally if we pick up that item, we shouldn't have an issue whatsoever. So let's compile and save. Play it again. F8 and select our character, select the AC inventory, and we have still one element. Okay, so I finally figured out the reason. So it was partially because of this, because of the actual what's it called, check rotation I didn't do correctly. But there's also another thing that we forgot to do is currently if we look at our data assets, they're still empty. They're not actually taking up any space because we haven't initialized them. So to do that, in my case, we're going to do it in the level blueprint, which I wouldn't suggest doing normally, but this is the same trick I'm going to use here is the same trick you would use anywhere to set this up. So what we do is we start off by saying add paper tile map component, attach that right here. And what we want to do is we simply need to tell it what paper tile map we're using, which is our tile layout, item layout, which we made. And we don't need gravity, but it's not going to change much. We simply need to tell this as a reference here, a reroute, and we're going to go through each asset we have to actually inform it, well, hey, this is our data asset list. Here you go, try and actually go through them and set up their values. So this can be done anywhere, except here we're going to go through a list of them to get them. So if anybody has ever been wondering how we get all our data assets, I'm going to show you how right here. So we're going to search for something called get asset registry. And what this does is it gets a reference to all the data assets we have in the actual project, I think, if I understand correctly. And so what we're going to do is we're going to say get assets by path. And we're going to use that to get a reference to the assets we have in here. So to do that, what you actually need to do is normally the best way to do this is inside of your project settings right here. You go into your asset manager and you would actually add a new thing with your assets. So I'm just going to go ahead and show you how it works. Here we're going to call it items. This doesn't really matter too much. We choose our base class, which is DA_item. And the main thing we want is actually going to go to directories and we're going to select the folder we're talking about. So inside of inventory, we want data assets and we're going to copy this. And now we can actually get rid of this. We don't need it anymore because it doesn't actually, at least from my testing, it doesn't do anything for us, but it might be useful if you're trying to actually load more and in actual game time, let's say. So instead of none, we paste the value we just got and we go through the loop of these actual data assets. Now, as they are currently, this is an actual data asset type. So what we need to do is we need to say get asset, and this will convert it to an actual asset itself. We then need to cast to DA item, so we know which one we're talking about. And we can then call our function, which says determine shape. Now, alone determine shape, as I said, can't do anything. It needs the component, and the component we're looking for is right here. So we just plug this in. Now, in the event you're doing this without, let's say you have in-game somewhere else where you have this value simply stored. Let's say you have in our item right here, we could do it. We just have to get a reference to our data asset, which we have here. And we could perform the exact same action, but we would just need to create the actual components here we would just create it in here and call the same logic. So in this case, we won't do that because we can just use the actual level editor, or the level blueprint, sorry. So normally now, if we compile, we have our first person character. He has our one item still with 5. If we go and pick up our second one now, it should be aware of what's happening, and it should have had a second one. So now we have 10, and we have 2 because it knows that there's not enough space. So I'm just going to run and test that because it did look like it worked, but there was a bit of an issue. It was saying that it was in 0, 0, and because I is actually 4 in length, it should have been 0, 1, 2, and 3 occupied by the first one, and 4, 5, 6, 7 for the rest. But it was on number 3, which was a bit strange. So I'm just going to check that our layout is done correctly for I. So it indeed has 0, 1, 2, 3. So it has 4 of them. So that's correct. But then inside of our data asset, let's check if it actually worked. It has 4 elements as well. That's very abnormal. That's incorrect. That is not how it's supposed to be. Okay, sorry. So I think I mixed these up. The actual size is wrong. These are inverted. Yeah, so that's the issue. So you need to invert the layers, and once you've done that, so I should be 1, J should be 0, and if we try that again, we should have the correct values show up this time. So if we select our player character, down in our inventory, yep, so here we go. Now we have 4, which is correct because it's at 4 of distance, and that'll do the job correctly. Okay, so before we move on to the actual widgets, I realized something that could be modified in the actual pickup system. Let me just show you right here how it currently works. If we open our inventory, in the function WhereShapeFits, how this actually works is it will check for location 0. So we'll look for the origin, let's say, of our actual item. So I'm going to pull up one right here, for example. If we look specifically at the J, or maybe the J isn't a good example, but in the case of the opposite, so the L, we have a point here instead of here, meaning 0 doesn't exist. And if we actually try and place that in our inventory, it's going to actually appear next to the item itself and not, let's say, how to put it? I'll try and show it with our actual thing here. Just give me a second. We'll just select 1. No, that's 2 points. We just want 1. So if we run an extra layer here just to test, if we have a piece like this and we try and add a 1 of 3 here, well, with the current code, it would just add itself right here instead of taking this actual slot right there. So to fix that, what we need to do is we actually need to inform it which is the first point here. On the first line, where's the first point we can find? And so to do that, what we'll have to do is we're going to make a small change, and that is right here. Instead of doing array element directly, what we'll do is we will get our shape right here, and we're going to get the first index. And by getting the first index, because how we calculate the index in the first place is we go left to right, top to bottom, we'll automatically get the first point to the left on the first line. And so if that is not on 0, 0, then we can subtract that from here, like this, and look in here. And what that will do is it will check whether, for instance, there is some place under offset that we can fit this in instead. So we just need to modify this now because we can actually have an item outside of the valid index. So we need to slightly modify our find here. And we can have it like this, but we also need to add a second branch that says, well, do we actually find it? Because if we have no items, it will actually look outside of the actual box itself. So we need to make sure that this can only happen when we actually found the item. So it's a quick change, but it makes a lot of difference when it comes to showing the actual items in the inventory. So let's well, we can't exactly have a look at that, and I actually need to get rid of our extra one that we just made, because otherwise the offsets will be wrong. So we can close that, we can now move on to the actual inventory itself. So the first thing we'll do is we will make the actual inventory in the grid appear, and we'll set up the the exposed on spawn variables here, and then we'll be able to close our AC inventory. So inside of widgets, we'll be opening the inventory and we'll be opening the grid. So let's go and do that. So in widgets, inventory and grid. So as last time, the inventory is going to be the basic thing with a scale box, which we will set to fill, and a canvas. And finally, we'll add a grid, or the specific grid that we have, so a UMG grid. We will center it by changing the anchor, and we'll change its alignment to 0.5 and 0.5, and put it to 0, 0, and I think it's 800 by 500 if I remember well. Yeah, so 800 by 500. Obviously this can change if you want a bigger inventory, but we'll be setting that up in a second. So now inside of the graph. So inside of the graph we need to set up a few variables, not too many, just a few. And so those variables will be first the actual inventory itself that we're going to get from our AC inventory, which will be of type 2D vector with in a form of a map, with the second point being the ST item. So make sure we expose this on spawn, so instance editable and expose on spawn. That's how we make it appear here by refreshing. Or actually it won't refresh if we don't compile first. Now if we refresh, we have our inventory. So we're going to need a few more. One, the size of the actual grid. So that's going to be, actually we'll just duplicate it, be easier. So inventory size, which will be an integer of type single, and we duplicate that and we'll call this inventory width. Now normally by default in inventory we already told it to be 34 and 10, yeah, so we don't need to worry about that. If this happens we can just recompile. It's just because it thinks that it's still an inventory of type map and we didn't, so just recompile it and it will work again. So they're both exposed on spawn as well, and they appear here. So now we just want to plug in our inventory, our size, and our width. And we need one last one if I'm correct. Yeah, so we need also a reference to our actual AC inventory as well. So we're going to add that. This is as AC inventory. And this is just to avoid doing event dispatches because it's a bit easier to do it here with just the AC inventory reference. So AC underscore inventory, and select the first one. Make sure it's also exposed on spawn. Refresh this, it will appear here. Search for self, and that'll do it for our actual actor component. We don't need it anymore. We can compile, we can close it. We can also close the new map. We don't need that as well. Also, one thing worth noting, if anybody is doing this differently with a different package, let's say a different set of assets, if you have multiple paths, you can just say get assets by paths plural, and you just have to make an array, and you can do the same trick as here but with multiple paths. So I thought I'd just share that in case anybody is doing more assets than us. So compile, can close this, don't need it anymore, and now we can get into the actual making of the inventory, let's say. So before doing that, we have a few functions we need to make in here. So they're not very complicated, but we need to do them anyway. So inside of function, we're going to have drop item, we're going to have remove item, and we're going to have add item. And so what these do, they just do exactly what the name indicates. For drop, we're going to have the input pin be the actual structure, just like we had in our actual AC inventory. We want to have, well, we'll call it input, like, yeah, input structure, we'll call it. And it's going to be of type ST item, not ST underscore item, sorry. There we go. And with that, actually, let me just double check. No, sorry, so we don't do that. We use an actual, we just use the key, sorry. Yeah, so we'll just actually use the key instead. 2D vector, 2D, sorry. Vector is before, so it doesn't work. So this is just going to be the key. And with the key, what we'll do is from our inventory, we will say find. We'll use the key that we get, align these up, and we'll plug this into our drop that we have in our AC inventory. So get a reference to that and say drop item, and we just plug the structure in. Now, because drop item doesn't perform any change in the inventory itself, we're also going to have to call remove item here, which it will do the actual removing of the item. So this will also have a key, so we can just call it key and just plug in our key into there, and we'll just modify that one next as well. So for this one, very simply, inventory, remove, get our key, and align it all up correctly. And finally, we then say remove from inventory here. And because we're specifically removing an item, we want to modify the state because the item will no longer be there. So we get our key and plug it in here. Last one we need is add item, which is going to be very similar, but this time we need the actual key and the actual structure. So we need key and value, and the type will be st item again. Then we get our reference to our inventory, we say add, we get the what we'll call key and we'll call value, and we just plug this all in. And then just like with every other one of these functions, we're going to get a reference to AC inventory and say add to inventory. And we're going to take the key and the value again, plug them both in, align these up, and we are done for this entire thing. We don't need it anymore. We'll be able to move on and test it in a second once we set up our default grid. So let's go and do that. So inside of our grid, we want to add an actual usable grid. So we'll add a grid panel. Okay, so here's where most of the logic is going to happen. So the first thing we're going to have to do is, because we're going to need to go back to the inventory in a second, the UMG inventory, sorry, we need to add the event dispatchers. That's what we have to actually do first. So for the event dispatchers, we'll call them ed underscore item dropped, and they're pretty much going to call the functions we just made a second ago. This is going to have a key of type 2D vector. Then we're going to have ed item removed, and that's going to have once again a key right here. And finally we have ed item added, which is going to be the key and the structure itself. So st item, or we'll just call it value, sorry. And this is going to be of type st underscore item. So these are what we're going to call in here. Now if we go, now that we compiled it, if we select the grid, we have our functions that appear right here. So we're going to call all three of those. There we go. So this is the three actions we can perform. So let's just finish this before we move on. So this is obviously taking place in event graph, sorry, if I didn't mention that. So what we want to do here for add item, we'll call our add item right here. Now these don't actually have to be functions, but it's just easier to read if they are. So that's why I made them into functions. So there we go. Then we want to say on remove, we want to say remove item. And for the drop item, we will call drop item. So let's get drop item here. One last thing we need to do is in our construct, we need to actually inform our grid the information that it needs. So to do that, we first need to set those variables. The first one we're going to need is, actually let me just open it here so I'm sure, because we're going to need quite a few of them. First, we'll start with something we'll call moving item. And this is going to be, unlike before we did a drag and drop operation, we can't do that here because of how the grid-based inventory works here. So we're going to have to move it manually. So this is going to be a UMG item right here. Then we're going to have what we'll call current location. And this is going to be a 2D vector. And this is what we're going to use to move the item around. So let's just put these in the category we will call movement. With both of them in there. Next, what we want is we want the inventory. So this is going to be the same as before, 2D vector into a map into st item. We can then duplicate this, and we're going to call it grid state. And the second one, unlike before, it's going to be a boolean, like we did before, sorry, in the actual inventory itself. And we're going to need one last one, and this is going to be inventory underscore grid. Now the reason for this one is instead of being the item or instead of being the structure, it's going to be a reference to each of the UMG items that we have. So UMG item here instead of the boolean. We get a reference to our actual grid because apparently we didn't do that. So this needs to be is variable. It's going to need a reference to it. Then we need another variable we'll call type grid slots, or we'll call it grid slots. And what it will be is an array of all the slots, I think they're called UMG underscore, yeah, so UMG underscore slot. And what this is, it's going to be all the background widgets that we can hover over and click that are actually empty. Next, we need the the inventory size. So inventory size will be of type integer, and it will be a simple integer. Then we're going to have inventory, grid width. And both of these need to be visible in the event that in our inventory we want to have a, let's say, a different size, if we want it to be bigger than that. But because what we want to do now is already based on the actual inventory, then we don't need to do that. What we want to do is we want to set them right here by saying, let me get this up, set inventory. So this is the default one right here. We then want to, let me just actually put a reroute here and align this up. We then want to say set inventory size. And we'll do pretty much the same thing for the width as well in a second. We want to say set width right here. And then finally we're going to have an actual function which is going to be set up the actual grid itself. So this is going to be our inventory. So we'll get this one directly. And here size, get inventory size, and for inventory width we'll get grid width. Go. So we can compile, and we just need to go into our grid here and make a quick function that we're going to set up in a second, but it's going to be set up the grid, or just simply set up grid will do. So we'll call here set up grid. There we go. Compile and save. Oh, sorry, the target needs to be right here, otherwise it won't work. Compile and save, and now we no longer need the UMG inventory, we can close it. So one thing we can do before moving forwards is we can reorganize this. So this is going to be in a category we'll call inventory. Same for the grid state, same for the inventory grid. For the grid slots, we'll put in a category we'll call the grid itself, and the same for the inventory size, the inventory width, and the actual grid panel. And now we can move on to the actual function. So the first thing we'll do is we'll make it visible. We'll make it so that you can see what happens with the actual items themselves once they appear. So we'll start with that. We won't go through the whole list first. So the first thing we want is we're going to set up the grid. So before setting up grid directly, we need to set up the empty grid. So we're going to make another function for that. Empty grid. So for setup empty, it's very simple. We're going to do our typical for loop where we're going to set up in addition this grid itself. So we first want to clear it so that we're sure we're going from a blank slate because it's better that way. Or actually, to be fair, it might not be that. We don't actually need to do that because this is a map. So the map uses the add function which modifies the keys anyway. And normally we shouldn't have any extra values, but to be fair, to be safe, we'll do this in case you want to change it at runtime. It will just reset itself and rebuild from there. And the same for the grid slots. We want to clear them because we're going to be creating new ones right now. Same thing goes for the grid. We want to get our grid panel and we want to clear it, clear children, because we don't want to have any extra pieces there when we add new ones. And now we can get started for the actual adding. So start with a for loop with our inventory size -1 because we need indexes and not a quantity. So plug this into a for loop on the actual last index. Plug it in right there. And what we can do first is, once again, we're going to set our grid state like we did in our AC inventory, and we're going to say add. And we will split the actual value right here. And we're going to get local variables, we'll call L, column we'll call it, and we'll have another one we'll call L row. Now row is Y and column is X, and remember that because that's going to be used everywhere. So column here being X, row is Y. Line these up and we leave them false because they're currently empty. Now to do that, what we need to do is we need to create our widget now. We need to say create widget, and the widget we're going to make is going to be the actual UMG underscore slot. And later we'll be adding the actual key to it, but we don't have that yet, and it works at least visually without it, so we'll do that first. So the first thing we want to do is we'll add a reroute because we're going to need a few functions from this later. But the first one we're going to need is we will get grid slots here, and we will say add, and we will add our actual function or our actual new widget to that list. Next up, we want to add it to the actual grid. So we're going to say add child, no, we can't do that. We need a reference to our grid panel here. Add child to grid. And here we're going to plug in our row and columns like we made earlier. Let's get a reference here. So we need columns for columns and row for row. Line these up a little bit forwards. And next what we need to do is, like in our actual inventory, we need to increment the different rows and columns. So we're actually going to put this as a sequence, as right here. Let's just add a reroute here, because later we'll need to add some event dispatchers here. So for now we'll just add it here, and on the second part of the sequence we will do our test, our increment, sorry. So we'll get our grid width. If grid width -1 is double equal to our columns being the X, then that means that we're at the end and we need to reset it to 0. So columns becomes 0 and we increment row by 1. So just increment it. And on the other hand, if it's false, we increment the actual column like this. So now normally, if we play this, we won't be able to see anything because these slots are not visible. So maybe we'll go make some visuals for the slots just so we know what we're looking for. So for the slot, what we want to do very simply, we want a size box first. And the size box is going to be what determines how big it gets at maximum. And we're going to override it to 100 all the time. We always want it to be 100. If you want to change this yourself, that's fine. You'll have to change every value that we use from 100 to whatever you use. It's not a problem. Then we want a canvas panel because a size box can only have one child. So we need a canvas panel to have multiple. We're going to add an image. And before that, what you can do if you want to see this properly represented, because currently it looks like it's going to be 1920 by 180, but that's not true. We can say from our fill screen here to desired, and I'll put it to 100 by 100, like what we want. So to make this, I wouldn't say more visually appealing, but more, let's just say more repetitive and more regular in style, we're going to actually move the edges to the center, because otherwise it looks like they're kind of sticking, how to put it, on the, what's it called? Not on the edge, but if you have a proper grid with everything touching the edges, then the interior will look like it has a double layer, whereas the outside won't. So that looks a bit strange, so to avoid that, so to get that result, what we'll do is we're going to put this as a top fill, so this one in the top right here. We're going to set it to 4 on the left, on the offset, 4 on the top, and we're going to put the offset on the right to 4 as well. And we're going to make it a width of 2. So the reason we do this is that everywhere we have a bit of an offset so that it looks a bit cleaner, let's say. So we're then going to duplicate this, and we're going to do the same thing but at the bottom. So we'll put it at not 0, but we'll say, to make it easier, we will set the Y here on alignment to 1, meaning it'll be relatively the same as if it was at the top on the opposite. We'll set it to 2 on the size again, offset on the right to 4, offset on the left to 4. and position will be -4 this time. And I'll make it the same distance here as it is there. Now we just need to add the one on the side, so another image. Actually, we'll duplicate it, it's easier. And so for this one, we'll anchor it on the bottom left here. We will set the offset to 4 on the top, 4 on the bottom. We'll set the size to 2, and the offset can be left as is because it's the top left. Position just needs to be 4. Now, we need to make the offset 6, sorry, because otherwise they'll be overlapping one another, and we want to make them a bit transparent once we're done. So one more duplicate. Actually, this should be 0 here, I think, if I'm correct. Yeah. So you can change the alignment back to 0 here. For the new one, this needs to be 0, but the X needs to be 1 because we're going to be on the other side. Anchor it to the other side here. Position will be -4. Offset will be on the top, 6. Size 2, and offset on the bottom 6 as well. And that'll give us a nice center. Now, in addition, we can also, just to make it clear that we're talking about an empty slot here, we can center this, make it 2 again. We'll say alignment 0. So we'll center both of these. Sorry, no, we'll make 0.5 and 0.5. We will center this, and we will say, well, you're a size 40. I think I used 40, or a bit smaller than that. Yeah, so I used 30. This is up to you. You don't even have to do this. It's just mainly visual. And what we'll do is we will rotate it by 45 degrees, and we'll make a duplicate of it, which will be the exact same, but -45, back to 0 in positions. And now what we can do to make it all look kind of a bit blurry, we will set the render opacity to 0.4, and this is the result we get. Now, it's nothing too fancy, but it's easy to tell that this is an empty slot because of the cross. And the last thing we need to do, which is mandatory, otherwise most of this won't work, we need another image in the canvas panel, but we need this one to be fill. And this is really important. You need to make sure that it covers everything, even around this edges, because this is how we're going to know whether we hover this empty slot. So what we'll do is we need to make sure that this is set to visible, but we don't actually want to see it, so we put its render opacity to 0. Sorry, not its render opacity. We want to put its color to transparent. And so now with an actual visual and our grid set up, normally, if we call it in here, so setup empty, we should get a result where we see our actual grid if we press tab. So as you can see, this is the result we get. If we put it in full screen, there we go. So it looks correct. Doesn't seem to be any issues with it. It has 34 as we wanted. So that's the visual inventory. Next, we're going to add the actual current one, because normally we have an item here, an I block. So we need to make that visible. So that's what we're going to do right here. Like before, we want to clear out some of the old stuff. Not this one. This one we're going to need after, but we want to clear the actual grid that stores the visible widgets, because we're going to be adding them again. Now, then we want to get the keys, and we're going to go a for each loop. With the for each loop, we will say get L, we're going to promote this to a variable, not get. Promote this to a local variable we'll call L key. And then we're going to immediately say create widget. And that's going to be our UMG item. Now for UMG item, we need to add some stuff here because we need to tell it what key it is and what actual inventory it is. But we can't do that yet because we haven't made it. So we'll go through this function first, and then we will modify it so that it actually appears. So we want to promote this to a variable, which will be calling L current item. And then what we want to do is we want to add it properly to the grid. So we're going to sequence here. And the start of the sequence is going to be about, is going to be about adding it to the grid. And the second part is going to be about dispatching the events with the current item, right, like this. So to do that, we get once again a reference to our grid panel. We'll say add child to grid. The content we're adding is our local variable here, current item. And what we need to do here is we're going to need some like another reference to our key, sorry, which we're going to then break. And we need to convert this. Remember, X is for columns and Y is for rows. So we need to align these up as best we can, even though it's not very pretty to do. So let's just move that down a bit. We'll just put this here. It's more readable, I think, that way. Then one thing we absolutely need to do is we need to change the layer of our actual item, because otherwise the item and the, not keys, but the slots in the back will be mixed up because they'll be on the same layer. So we need to make sure that we set layer here to 1 instead of 0. Next up, we need to do one last thing for this, and that is we need to tell it what is going to be the actual size of our item, because our item is multiple grids, not grids, but multiple slots long, especially if we're talking, for instance, about the I block, which takes up 4 slots. So to do that, we need to inform it that this grid item right here actually has a span of 4 columns. So to do that, we need to set row span as well. And to do that, we have a function that we made inside of our actual, our data item, which we made. So we're going to find that, no, not that one, we just want basic find, from our inventory, because that's where the key is coming from anyway. And we're going to break this, and what we're looking for here is get max size. And that's what we're going to plug in here. We're going to get the rotation, and we're going to use this to, well, say how big it is. So we'll start with the column, because that's the top one, and then we'll put the actual span of rows like this. Just add a reroute so it's more readable. Align these up, like this, and we'll just add this here as well to make it better. There we go. And that'll do it for setting up the items itself. We want to make sure, that we default override, because it doesn't matter what the rotation is. We want to make sure that it is 0, 0 here. Or at least it's considered at 0 rotation, because it's a bit strange how this works, but because how we're going to set up the item is going to take up the entire canvas. Let's say we're going to fill the image. And if we end up changing the size without the override, it's going to actually crush the image. Even though the image will be rotated, it will be not sized correctly because the canvas doesn't care about the rotation. So it's a bit strange to explain, but I won't really be able to explain it without breaking it, so we're not going to do that. But just know that this is why we do it with default override every time, because we're not going to be clicking on the canvas, we're going to be clicking on something else, which we're going to set up with our visibility here. That's what that's for. And with that, we've actually set up that will do it for setting up our actual item. So what we can do now is we can actually just set up our default. I think in here we need it as well, so we'll just do that very quickly. We're going to add some variables here. Well, one variable, which is going to be the key. Also, we can make sure all these images are not variable because we don't need to modify them whatsoever. And the key will be of type 2D vector, and we want to make sure it is instance editable and exposed on spawn. And we'll have to come back to this later, but for the sake of just making things visible, we'll just do this. So here, if we refresh this, we have our key, we can split it, and we'll just plug this into it as well. Move this to the side. Okay, so now what we'll do is we will set up the basis, at least for showing the visibility of the item. So to do that, we need to open it up. Start with that. And we will start right here. So the first thing we need is a size box. And this size box is what will allow us to know how big it is in the given conditions. So we can put a default of, let's say, 400 by 100. Then we can change the size to desired. And this one, you can put whatever you want. We're going to be modifying it once we start it up anyway. So canvas panel, next. And inside the canvas panel, we want an image, which is going to be item image. So this one, we want to make sure the anchor is fill, set it to 0 and 0. And then we want to add a text box here for the actual quantity, because we want to know how many items we have. So this also needs to be visible, and we'll say TB for text box underscore quantity. Set its size to 50 by 50, and the font we'll leave it Roboto and 24. We can also add, I like to add one in outline of here so that it's visible if it's white. Put a value of 10, but we're going to be moving that around. So we want to make it, be aligned to the right as well, because it's going to end up in the bottom corner in most cases. So one thing we need to make sure is that all of this is visible, because we're going to need all three of these items to be modifiable, is variable. This is going to be img item, and we can just go into the graph now. And so that the graph, there's going to be quite a few things to do as well, but we're going to start with simply making the actual thing visible. So we'll start with that with our parameters. First, we have the key, which is going to be of type 2D vector. Then we have the structure, so the value we'll call it, and it's going to be st underscore item. So make sure both of these are exposed on spawn in both cases. And that will allow us to, in event begin play or event construct, to set up everything we need. So the first thing we'll do is, with this, we want to have another variable, we're not going to use it yet, called grid units. And this is just how big each individual slot is. So in our case, it's going to be by default 100. And what we'll start by doing here is we're going to set up just the default for the text and the actual image, and then we'll do the rest later because that's going to be a bit more complicated. So I want to set everything else up first. But first I'll show you the item appearing, and then we'll move on to the more complicated stuff. So we're going to get our, not our image, but our text box here. And we're going to say set text right here. And the text we're going to use is from our value. We're going to say break. We're going to get our quantity, which will be converted to text by dragging it directly in there. There we go. So this is the first thing we're going to do. Then, once again, with our actual reference to our value or our structure, we're going to get the data assets and we're going to get the texture. And with the texture, what we'll do is from our image item, we will say set image, set brush, by from texture, and we simply plug in our 2D texture into this. Go pull that here, and that'll do it for the visuals. Now it's not going to be perfect as is, but we're going to be setting that up in a second for the more complicated part. Actually, no, one last thing we can do is here we're going to need a delay until next tick. Now this is from kind of testing. I don't know why, but the function we're going to add here after doesn't work without this small delay. So I'm not exactly sure why that is. But what we want to do after that is, once again, from our data asset, we want to call get max size. I'm going to need our rotation, even though we're going to once again put it to default here, because this is going to be how we're going to set our actual size box. So we're going to say set override of the height and set override of the width. Width can go first because it's for columns and height is for rows. So we'll just reroute these like this. Move that up. There we go. And actually move the whole thing apparently. There we go. There. So to get these, and this is why we need the grid units, is we need to multiply the actual quantity of X, Y, and Z being 1, 2, 4 to the actual width here. Because otherwise this will be times 4, and we don't need it to be times 4, we need it to be 400 units long. So we'll just copy this, do the same thing for the rows, and then we can just plug this right into the height. And this should do the trick for all the visuals, but to make it work, we actually need to inform it what the keys are. So we'll get our key here, and for the value, we're going to just have to use our function right here, or our find, sorry, and plug that into value. Sorry, Shift D, line that up, go. And normally if we play now, we have our item that shows up. So currently we can't do anything with it, but it is appearing as intended. If we go and pick up our second item, the same thing should happen. We have 10 and we have 2. Exactly how we wanted it to appear. It's working as intended. So now let's move on to the more complicated stuff, which is going to be moving the item and all the rest. Okay, so now we start moving our items. So the first thing we're going to do for moving our items is we're going to start by doing the empty slot and everything concerning that. That way it's out of the way. You don't have to touch it anymore because it's probably the simplest part to do, but it's crucial to get everything moving. So first what we want to do is we want to make an override function, and we're looking for specifically on mouse button down. And so this is what it will look like. It will create a function itself right here. And we don't have much to do in here. We just need to do the conditions of what we want to happen. So for that, we need to make some event dispatches. But the first thing we can do is on mouse events, we're looking for the effective button, which is going to check when we call this event, which button is being pressed. And so we're going to look for whether the left mouse click is getting pressed. Now, if left mouse click is getting pressed, what we want to do is we want to say, well, we just pressed the left mouse button and we're going to dispatch that event so that we can control it inside the actual grid. So to do that, we need an event dispatcher. So what we're going to do is we're going to call ed underscore, I think it's left mouse button pressed. And what this needs is it also needs to know which key we're talking about. So we need to add a parameter, which is going to be the key itself. And it's going to be of type 2D vector, as all the other keys are based on that. And so we can call that here on true. We plug in our key, and that's all we have to do. The last thing, what we do need to finish one thing is, if we don't do anything here, it's going to consider that we didn't succeed in clicking. So we need to say that this was handled. And we'll then do another event. And so then we'll do the same thing, but with a right click. And in the event of a right click, we'll be telling it, well, hey, we want to actually rotate the item that we're moving, because we want to do that at the same time. So to do that, we're going to add another branch here. We're going to copy this. We're going to replace left mouse with right mouse button here. And for the input here, we need to say get mouse event, which is just like any other parameter. Plug this into condition. Make a second event dispatcher, which we'll call ed rmb for right mouse button pressed. We want the same here. We want a vector 2D, and it is the key. So we call it right here, get the key again, plug it into here, on true, and once again we will copy our return because otherwise it won't know that it worked correctly. We can then put this into false, right here. On the event nothing happens, we still tell that we clicked something valid, let's say, because if we don't, then it means we can move the mouse and move the camera, which we don't want to do. So this does it for our on mouse button down. And then we need to go to the event graph, because we're going to need one last thing, and that is we need to know when the mouse enters these slots, because we need to know how to move the items according to that. So we're going to need another override, and this is on mouse enter widget. And so the reason how this works is it will check whether there is anything visible, which is the reason why we added the full image here, because otherwise it would only consider we're on it when we're over this specific line or this cross. So we make a whole image that wherever we enter here, it considers the enter. So to prove it that this works, we can put a print here, and we will open this, open our inventory, and once we hover from one widget or one of these slots to another, we get a hello that prints. It won't happen here because we have an item on top of it, but here it will. And so that's what we're going to use once we start moving the item. We'll be able to tell, well, hey, we moved from this key to that key, so we know that we've moved one to the right, one to the left, etc. So to do that, we need another event dispatcher, and we're going to call this one just ed mouse enter. It's going to be of type, once again, 2D vector. We need the key, and we're just going to call it right here. Place the key in, and that's all we need to do. We can now compile and save, and we no longer need the slot, so we can close this entirely. Now in the grid, we need to tell the grid how to handle this information, which we're going to be doing right here, which is why we left this extra space open just for that. With the grid, what we want to do in our setup empty, we want to call these functions and assign them. And so we're going to assign these functions in real time. We'll add them here. I'm just going to actually put these in a category we'll call setup, and both of these will be for that. And what we'll do is we will bind event. We will say mouse enter first. There we go. Plug it in here. And we're going to promote these all separately to be their own actual event because they need to be separate. So create event. And what this will be is we will have to create one. So create a matching function. Rename it to receive, so R, mouse enter. And we're going to put this inside of a category we'll call received. And we're going to add a subcategory by adding a bar here. I'm not exactly sure what it's called. It's not an I, but it's a bar. And we'll then add a subcategory which we will call slots. And so that will make it appear like this. We can then duplicate these 3 times because they're the same keys. So this one will be left mouse button pressed. And the third one will be R, mouse button pressed. So let's just add the underscore. So all 3 of these will be now assigned to the different inputs here. So we then want to say bind event LMB. So LMB will be assigned right here. Just give it a bit of space. So create event, and we're looking for the, sorry, I accidentally misclicked there. We're looking for left mouse button, so call it right here. And finally, we need the last one, which is bind event RMB, which will be the same thing right here. Let's just move it a bit. Create event, and we will look for RMB this time. There we go. So that does it for assigning our functions. And let's just set them up straight away. That way we don't have to bother with anything else. We'll know exactly how they work. I'll explain it as we go through. So for enter empty, all of these actually, to be fair, start off with checking whether this item is valid. Because if it's not valid, we don't want to do anything because we're not moving an item. So we don't need to do any logic here. So first we'll check if it's valid. If it is valid, one thing we need to do first, I actually forgot, the current location by default needs to be set to -999, -999. So this is just a value that I'm putting. If you want to have it different, that's fine, but this is just kind of a default value that we know is different from a valid location, because it's very unlikely you'll have a grid size of -999. So we'll just use that as a kind of default value, because that will tell us whether the item is currently starting to be moved or has already been moved. So if it hasn't, so if it is equal to this -999, sorry, I can't remove that. If it is equal to -999 when we enter, then that means that that's going to be the new current location. So we need to go here and say current location is equal to the actual key that we get, because that's where we're hovering, that's the location. So if it is and its default value, we just simply set it. Now, on the other hand, if we are not on the default location, that means we already have a location, so we need to move our object accordingly. So to do that, what we want is we need the current location, which we're going to promote to what we'll call the old location, so that we know that we can then subtract it later from each other so that we determine it correctly. So we'll then copy this because we're going to tell the new location, we're going to tell it what the new location is, but we've saved the old one as well. So then what we want to check is we'll get our moving item, and we need to slot as a grid slot here, because this will allow us to tell it to set its location, set its column. But I realized sometimes we need to check if it's valid first, and not just the moving item. We specifically need to check if the grid slot is valid, which I couldn't figure out why, but that's just how it is. So with this, we'll say set column, and then we will say set row. Sorry, set row. There we go. And so to determine these, we're going to need an extra function, I think, or no, we don't need an extra function yet. We'll need a function later. So to do this, once again, we'll need a reference to our grid slot here. Now, because this is going to be called here and how Unreal works, because we're using this as a pure cast, we can say, if this is valid here, then we're calling this for these functions, so it's fine as well. So we want to get column, we want to get row, and with these, we're going to be converting them to a 2D vector. So we're going to make 2D vector, there we go, and we will plug column into X, row into Y, align these up, there we go. And what we'll be doing is we will be adding to this the actual result of the current location minus the old location. So current location is the new slot minus the old one, so where it was previously, and we'll be adding that difference to the actual current location of the widget itself, or of in the actual grid panel. So then we can just split this struct, plug the X into column, plug the Y into row, and with that, the item will now move once we set up that we can actually pick it up, because we currently can't do that. So the next step is we'll do our left mouse button pressed and our right mouse button pressed. So we can close the enter here, we don't need it. We can close our setup for empty. We still need our setup for grid because we need to do this right here, which hasn't been done yet. So for right mouse button, let me just open that up. So for right mouse button, what we want to do is, once again, we want to check whether moving item is valid, because otherwise we don't want to do anything. And if it is valid, we're going to call a function here that we don't have yet, so we'll add that in a second. Once we have our moving item set up, we'll add it. So what we need is we need our key. So get key here. So we're looking for our actual variable. We're going to break it. And with our moving item here, once again, we will say slot as grid slot. And this time we don't need to check if it's valid. We're going to set column. We're going to set row. And plug this all in right here into is valid. Into is valid, sorry. And for the row, once again, we put in Y. And for the X, we put it into column. There we go. So what this will do is here in valid we'll add rotate item, which is why we need to do this after. Because what this will do pretty much is it will inform the item once we rotate it to, because how the rotation works, if let's say you pick up the item and your mouse is on the furthest right point of the item, then if we rotate it normally, it would just rotate relative to 0, 0, meaning the mouse will no longer be over the item itself, which would look really strange. So we manually tell it to snap back to the item based on where it currently was pressed to move. So now we can go to right mouse button. Wait a minute, no, sorry, this is wrong. This should be in the other one. This should be in right mouse, not left. So just copy paste it. It should work because the key is the same name. So just call it again and it will work just fine. Compile and save. Yeah, it works, no problem. So in left mouse button, we can copy our moving item again because we always need to check whether that is valid. And if it's valid, we very simply have a branch. And for the branch, we're going to need a function. So we're just going to add a reroute here. And we can convert this to a function, I think. Yes. And this function is going to be called canPlaceItem. And this is going to be a pure cast. And we're going to put it in a category we'll call conditions. I think. Yes, conditions will do. There we go. And if this succeeds, if it's true, we're going to call a function that we don't have yet, but we'll create it now. It's called item stop, or yeah, stopped move. And so this will go in our left mouse button right here. We'll call it there. Actually, sorry, no. These two will go into the same actual category, and it's going to be called movement. Movement. There we go. And so we'll put both of these in here. So right now, kind of to move forwards, we need some functions in the item itself. So we're going to go ahead and do that. So there's actually quite a few to put in here. Okay, so before we actually go and do the item, which is going to be by far the longest part, I want to actually go ahead and make all the parts for the item first. So those include the visibility here and the drop down here. One thing actually we can do to make the item a bit better is we'll replace this image by default with the block eye. That way it looks more normal. So the first thing we want is the visibility. Visibility is by far the easiest thing to do, if I remember correctly. Yeah, it's not too complicated. It's mainly visual. So what we want to do is we want to start with a size box. And the size box is variable. We need to make sure it is. The widget override by default will be 100 by 100. And we can compile that and make sure that we set the desired just so it's easier to see what it will look like. Even though in this case, to be honest, there's not much to actually think about because it doesn't really do much. We just need to add an image here. An image. Thank you. And just plug it into there. Now by default, the image will be invisible. We want to make sure that we change the color to invisible, and by default we do want it to be actually black instead of white because we're going to be using it to cover and say, well, hey, the mouse is hovering, so we just darken the item we're hovering. So in addition to that, what we want to do is we want to actually make an animation here, and this animation is going to be to make the item blink once we're moving it. So we'll call that exactly the name, blink, and all it's going to do is it will take a reference to the image. We will get the track for the render opacity this time specifically, and we're going to start at 1, and at about 40 seconds, 0.4 we will put it to 0.4, I believe is what I put. No, sorry, we'll put it to actually 0, and then at 80 we'll put it back to 1. Compile and save. That's all we need to do for the animation. Next we can go into the actual graph itself. Now, yeah, so one thing we don't need is we don't need to have the image variable, I don't think. Just going to double check that. Yeah, so we don't need the image to be variable. No, we do. Sorry, we do. Because we set it up, I'm going to set it up so that if we want to modify the color, we can do that as well. So this is going to be image hover, we'll call it, because that's the whole point of it. That's what it's for. So what we want to do is we're going to need one event dispatcher first, and this is going to be mouse button, event dispatcher ed mouse button down. Now the whole point of this is that this will be used for interaction, not the actual item itself, which is why we're doing this here, and we're going to just dispatch the event directly there. So what we'll do for that, instead of adding a button to our widget, what we'll do is we will get the mouse button down, and we'll be calling the event dispatcher from here. So we will call it like this. We will say that this is handled. We need to make sure we tell it that it's handled. And what we want to do is we need to make sure that this takes in the same inputs, so we can just act like we're calling it from within the item, because it's easier to manage that way. That way everything is centralized as far as stuff goes, because most of the logic is going to be from the item itself. That way we don't need a reference to this back and forth. So to do that, we need to get these different variables inside of our event dispatcher. So the first one we need is of type geometry. So I'm not sure if it's this one. We'll give it a try. We add it and it plugs in correctly. We'll call this my geometry, just pretty much identical to the actual name here. Then we want mouse event, which is going to be a pointer event, I think it's called. So another variable, pointer event. Yep, so that's exactly what we want. And we will call it mouse event. Plug this into there and my geometry there. So Let's just refresh this. There we go, because I didn't rename it. Compile, and we have our event dispatcher. Next, what we need is to actually have the modify color and start and stop blinking so that we can just call them easily as functions. So we'll start with modify color, which will take in our image hover here, set color and opacity, and very simply it's going to just connect this pin here, and we have in color, and that's all we need. No, one last thing we need to do before that actually is we need to get our in color here. So this, we're looking for the variable, and we don't want to do this if we're performing the animation, because if the animation is happening, we don't want to mess with it by telling it to change its color. So we check is animation playing, sorry, and we put a branch. And if it is playing, then we don't do anything. If it isn't playing, then we can change the color like this. Compile and save. Then we want a function that says start blinking, and another one that says stop blinking. So stop blinking. So these are very simple. In start, we get a reference to blink. We say play animation. And we want to make sure that it is looping. So to do that, we set the number of loops to 0. Finally, for stop blinking, get a reference to blink, say stop animation, and we can call that here. Compile and save, and now we can close the visibility if I'm correct. Yes, I think we can. So we can just close visibility here, and we'll be adding them to the item on top of each grid pretty much. Next is the dropdown. Now dropdown is much easier. It's just simply going to be 2 buttons to inform us what options we have available. So we'll start with a canvas panel, and the canvas panel, don't have to do much with it. We want to call 2 buttons, so we'll just add 1 and then we'll duplicate it after. So the first button is going to have, well, both of the buttons are going to have text in them, and the text for the first one is going to be drop. That's what it's going to do. We'll make it use Roboto Tiny, and we'll make it 16, I think, in size. We can also move it to the left by removing our actual padding. I think I modified mine to be -8 on the left, so it actually goes to the edge. Like that. There we go. So make sure you set the horizontal alignment to fill, and set -8 on the padding. And with that, we have our text. So what we can do, we can also make the background color, I think, a bit darker. There we go. So something like that. And we'll make a duplicate of this very simply. And the second one will be location of Y of 30. And instead of drop, we'll be calling this remove. Go. Now, if you want to add more functionality, you can just add another button here. And then we're going to set it up with some event dispatcher. So let's just rename them so we know which one we're talking about. So button drop for the first one, and button remove for the second one. So now into the graph we go, and what we're looking for is 2 things. First, we need to check, first what we want to do, we'll start with the actual buttons. So on drop, we want on clicked, and on remove, we want on clicked. And we want an event dispatcher. We'll call drop, ed drop, which we'll call right here. We then want another one which we'll call ed remove, which we'll place right here. Right there, line those up. And with those out of the way, we just need one last thing, and that is to inform the item whether we are hovering or unhovering this widget. So to do that, we need our on mouse enter and on mouse leave. Now these are override functions, so make sure you click on the override and it'll appear right here. So we then want to say 2 more event dispatchers, one ed mouse enter, yeah, and the other one ed mouse leave. So call enter here, and call leave right here. So we don't need anything else other than just the fact that we enter or leave. we don't need any extra information than that here. And the same for obviously this, because we don't know what item it is in here, but where the event is getting dispatched to, we do know what item we're talking about. So we can now close the dropdown. We don't need it anymore. And next up is the more complicated stuff. So now is where we get into the actual thick of it. So first what we'll do is we'll reorganize all this into categories. First we have widget, and widget is going to be the item, it's going to be the size box, it's going to be the text. Then we want to have a category for parameters. So parameters are the keys and the grid units as well. Put all three of those in there. And finally, we need one last category, which we're going to be calling children. So for the children variables, this is just the visibility that we just made and the UMG dropdown. So this is visibility items, there we go. And it's going to be of type UMG visibility. And we want to make sure we turn this into an array. And this will go into a category we'll call children. There we go. We can duplicate this and we'll call it as UMG dropdown this time. And it's going to be a single variable because there can only be one dropdown at the same time. So UMG dropdown. That'll do it for all our actual variables. What we want to do here is we can set up the visibility. Now, actually, no, sorry, I made one mistake in the visibility that I forgot to do apparently. So we just need to do that very quickly. Open up visibility again. And we need to do something in the event graph that I actually forgot. So on the event construct, we're going to need to actually set the size block override. So set override height and set override width. And what this is going to be is we're going to need a variable for each of these. So we're going to promote this to a variable, promote this to a variable. You can line them both up, and we're going to promote these to make sure they're exposed on spawn. Not promote them, just make them exposed on spawn. And inside of UMG item, once we create them, we're going to tell them what size they actually need to be. So this will resize the visibility based on what size we're using here. So let's get into that. Let's add these to the actual item. Okay, so let's get into adding our actual visibility. So the first thing we want to do with our visibility is, one, we'll do it in construct. So to add them, what we need is we need to know where they go. So to know that, we want our value, we want to break it, and we're going to be looking for get shape from our data asset. And this will take into account rotation, which we finally start using now. And we will do a for each loop with it. And so what this will do is, relative to our canvas here, we're going to be adding them one by one. So we'll add a reroute here. And because we're going to be using it a bit later. First thing we do is we create widget, and we're going to create our actual UMG visibility. Now, by default, it has height and width override. So we just plug in our grid unit into both of them because we use it uniformly anyway. Next, we want to add these to our visibility. So add. And in this case, we don't need to clear these because they're only created once we actually set them up. So we don't need to bother there because the widget, once it appears, it does this once and never does it again after. So now we need to bind our events. So the first event we want is, we'll say bind event mouse button down. There we go. We will create an event for that, which we will call right here, create matching event. Let's open our functions. We'll call it R for received mouse button down. And this is the actual one with the geometry and the mouse event. So let's just give it a bit of space because it's a rather big one. So we'll just move all this a bit down. There we go. So right here, let me just reattach this. Move a bit closer. There we go. So next, because this is the only event we actually have here, we're going to say add from our canvas panel, add child to canvas. And what this will do is, because unlike before we don't have a grid here, we need to actually tell it where it needs to go. Now to do this, we can do it multiple ways. Either we could set it as a grid instead of a canvas panel, but we can also make it very simply by going here and multiplying our current location by our grid unit. And what we can do is we can get this right here, a reference to our actual item itself, and say set render translation, not transform, sorry, set render translation, which is just going to pretty much offset the actual image in the canvas itself. So it's the same as going into here, clicking on our item and moving it with this. So it's the same thing. It works pretty much the same way, but it's not as good as when you do it with a grid panel, but this is more than enough for an item that won't be moving within itself, let's say. Once that's done, we have finished spawning these items. We just need to plug this into the complete, and that'll do the trick. So once again, this we'll put in a category for received. And now we can get into the other functions, which is where most of this actually happens. So we'll move progressively to it. So we'll actually do our mouse button down first. So on mouse button down first, mouse button is kind of the basis of everything because we don't do any actions without actually clicking. So we want to get affecting button once again. And what we'll do is we will say if you're double equal to right mouse button first this time, we'll then want to open a drop down. Now, on the other hand, if we do not open a drop down, what we want to do is we'll do the same thing as earlier. We'll copy this. We'll put left mouse button this time. We'll say get mouse events. Now, because we copied this event, by the way, unlike before, we don't have a return value which we need to say handle to. So we don't need to bother with that. Now on true here, we're going to have to make a function which we will call start moving item. And this is going to be, well, the key thing about moving the item. So we're just going to set the drop down as well, and then we'll move on to that. So here we call start moving item. For the drop down, which is going to take place here, very simply, if the drop down does exist, which we have a reference to here, convert to validated. If it does exist, we want to remove from parent. And if it does exist, if it doesn't exist, sorry, we want to create widgets of that same type. So UMG dropdown right here, plug it in so that it lines up. There we go. And so if we succeed in placing it, we need to promote that so that we save it so we know it's there. And then we want to add to viewport. Now, just like before, if we do this by default, currently, let's see if what happens. If we go ahead and right click here, we don't actually have anything happening yet. So I made a mistake in the actual visibility here. We need to actually wrap the hover in a canvas panel. So we want to go and right click on it, wrap with canvas panel. And we want to make sure that the pivot is in the top left and we want it to be 100 by 100. So we can then, I made it visible just so I could see it. So just to make sure, you can run it again and we can see that the widget is indeed there. So we can make it invisible again and close this. Normally we should be good again. And one other thing I noticed while I was testing is we also need to change the pivot here for the canvas panel from 0.5 to 0 and make sure it is like this. So now normally if all goes well, if we go and click on this, we have, as you can see on right click, we have our actual drop and remove that appear, but they appear in the top left because that's where the actual canvas panel is. So we need to tell it, well, hey, you don't want to be there, you want to be where the player mouse is. So to do that, in our right mouse or receive mouse button down, we can tell it to do exactly that. So to do that, we want to drag from our add to viewport. We want to say get mouse position on viewport. And what we'll do is from a reference of our dropdown, we will say set render translation again to, well, our value where the mouse is. And because it's got its pivot in its top left, it will mean it is just below the mouse button to the right. So the final thing we need to do here is we need to bind our actual events because we made quite a few events in our dropdown. So the first one is going to be bind event drop. Then we have bind event remove. Next we have bind event hover, I believe, or enter, I think we called it. Bind event enter, yeah. And bind event remove, I think. Yes. No, we already have remove. Bind event unhover, sorry. Leave, sorry. There we go. So all 4 of these need to be entirely different functions, and so we're going to have to create those events. So we're going to create event, going to create a matching function, which we will call our drop. So this is our drop item. We can, drop item we'll call it. We can then duplicate that, and this will be remove item. Then we'll say r underscore hover, or hover item more like, and r unhover item. So unhover item. So this will be all 4 of those. They can all go into our received, like this. And for now, we'll leave them closed, and we will bind our events first. So we have our drop here. We can copy paste it, and we're looking for remove item. Then we will create another one here, which will be this will be hover. That's what we called it, hover item. And for the last one, it will be unhover item. There we go. Compile and save. And so that should do all our setup here. Now if we go and try that out again, if we right click, it appears right under our item and no longer in the top left corner. So now let's deal with the actual dropdown. If we currently go and say right click here, we delete it, but we need to also check whether we do that from another item. So to do that, we're going to make a function that just deletes it from outside. And that's just going to take us a second to do, but let's just do that. So this is going to be called remove dropdown, very simply. All it's going to do is it's going to get our dropdown right here. We get the validated reference, and we simply remove from widget if it's true, from parent, sorry, and we reset it to empty. That's all, and this is just going to be used if we need to delete it from outside. So what we'll do here is we plug this into the received as well. We'll just leave that in the received for now. So actually, we need to change something here. Hover item isn't correct. This is hover dropdown and unhover dropdown. We're going to actually have another function later for specifically the hover item itself. So let's just deal with the actual dropdown like we did last time. In the hover dropdown, what we want to do is we'll start with unhover. So in unhover dropdown, what we'll very simply do is we're going to set timer by event, and we're going to promote this timer to what we'll call drop down timer. And what this will do is it will simply clear out the drop down after 2 seconds of no longer hovering it. So we're going to create event, and the event we will call is the one that we just made, called remove dropdown. Now, on the other hand, in the hover dropdown, we want to check whether this down timer, which we'll put in widget, is valid. If it is valid, then we will tell it to ignore. If it is valid, we will tell it to clear the timer and validate timer. True. If not, we just ignore it. We don't do anything. So what that will do is if we go and right click now, if we hover it, it'll be visible. If we remove our mouse, it'll disappear after 2 seconds. And so now we have our dropdown appearing correctly. Now what we can do is let's do the hover. So we want to check whether the player is hovering the item. So we'll make that visible by having the actual visibility darken itself. So to do that, we need an override. We want to have mouse enter, and we want to have mouse leave. Now these will automatically appear once again in the event graph. And so we're going to create a function for that, which is going to be hover item. So this is why we renamed the other ones. Sorry, not like that. Hover item. Duplicate it, and the other one will be unhover item. So in our event graph, hover item goes here on enter, and unhover goes on leave. So let's just line these up, and there we go. So for hover item, what we need to do is we'll go and make a for each loop through our visibility items, and we will tell them to modify color. So modify color, and so this is on its visible, so we want to set it to I think it's 0.4 will do. And we can copy this, and on unhover we'll do the opposite, and we will make it invisible. So let's go and set that to invisible. And normally if that all worked correctly, if we go and play, we have the object that darkens once we pass over it. So now it's just a matter of getting it to click and react to these different buttons. So let's go ahead and do that. So we'll start by getting it to move, which is probably going to be the hardest part, but we'll get there eventually. So we'll put these two in a category we'll call widgets. There we go. We can now, I think we can't hide these yet because we still need them. So, but before doing all of those, we need to do some other things first if we want to do the item moving. So we no longer need these drop down ones. Moving item is probably the most important one that we'll do right away. So start moving item is pretty short, and it's going to be the kind of main part of beginning the movement, which is controlled in the other place. So if we want to move the item, first we want to remove our drop down. So we'll put that here, and we're going to have some event dispatchers, but we don't have them yet, so we're going to get there in a second. Next thing we want to do is we want to make sure that our canvas panel is no longer visible, or at least no longer hit testable. So we will say set visibility to not hit testable, self and children. We want to make sure that nothing in the item is hittable with a line trace. And so in addition to that, we want to make sure that our visibility items here start blinking, because we want to tell them that we're currently about to start moving the item. So we'll call this here, and we'll say start blinking. Now, if we run this like it is, it will start blinking, but I don't think it will move yet because we haven't told it externally inside of our grid that we've started moving. So that's where our actual event dispatcher will come in and start that off. So we'll create an event dispatcher, which we will be calling, let me get this right, ed underscore moved. We'll just call it moved. Then we'll have, just for the information, all we need for this is this item. What is the item we're trying to move? So that's going to be of type UMG item. And we're going to call it right here. And it's going to be self right here, because this is the item we're trying to move. So we'll just make the other event dispatchers, that way they're ready. So next we have removed. So ed removed. And this is going to be the exact same type as before. This, we just want to know which item we're removing. Next we have ed dropped, which is going to be the same thing. Which item has been dropped? So this again. And finally the last one, which is going to be of item added. So ed item, just added. And this will be of type the same thing, this UMG, because the UMG contains the value and the key. And in the event of moving in our grid, we need to modify our actual inventory grid, so we need to know which widget we're talking about. So just instead of bothering with searching through our find every time of the inventory, we're just going to tell, well, we're looking for this item anyway, because we have all the information available there. So now is where we go back to our grid and we actually bind these event dispatchers, because previously we set up the ones for the empty, but now we need to bind the ones for the current item. So in our local variables here inside of setup grid, we're going to bind our different functions. So we'll start by setting up our event for added. Let's bind event added. Then we're going to bind, actually we'll create our event here, and the event will make one for it. So create matching function, and this is going to be called r underscore item added. And because all the items use the same thing, we can add them to received first. We can duplicate this, say item removed, duplicate it again, say item dropped, and duplicate it again, say item moved. So this is our 4 functions that we'll use for the event dispatcher. So this is added, then we want to bind removed, which will be the same thing, but with our other variable or other function, sorry, called removed. Then we have the same thing for our dropped, not that one. We want to call dropped bind event dropped. So create event dropped. And for the last one, which is moved, so bind event moved to our actual event we made, so create event and moved. Go. So once we plugged all this in, we're going to need one last function here, but we don't have it yet. We'll add it once we get there. Let's go and do our moved, and then we can start actually finally moving our item. So inside of moved, the first thing we want is we need to tell this right here, our grid with the items, to get values and to tell the other ones that they need to be hidden, because if they're not hidden, then we won't be able to move over them because they will block, and we still want to be able to move freely even if the actual item can't be placed on top of those. So first we'll check if it is valid, because sometimes that can be an issue. If it is valid, we simply want to say set visibility true. We want to say set visibility to not hit testable self and or children. Then if this does work, so once this is done, we're going to get our this reference, and we're going to say that moving item is this. We also, which we're going to do later, is we're going to tell this to remove item from inventory. So that way that when we try and place an item, it won't be considered as existing there because we're moving it. We then want to slot this slot as grid slot, and the reason we do that is because we want to make sure that it appears above the rest. So we say set layer to number 2 this time, because number 1 is the items, number 0 is the actual background. So with this, normally we can go ahead and actually modify it. So if we go and left click, we can actually move our item around. Now currently it can go off with no problem, but the limit is it won't be able to go to the left or up, because the index being in the top left, it can't do that because it doesn't exist. But on the right, it can go off as much as it wants. And even if it can go here, we're going to tell it that it can't place there. Currently, we still can't place because we haven't set that logic up yet. So with that done, we now have an item that can move. So now I'm just going to go through every different function. We're going to create everything and kind of finish things up now, because it's kind of the last stretch. It's still going to be a long last stretch, but now we can just start moving forwards without really stopping for anything. So inside of our item again, we already have all our event dispatchers now. Now we just need to finish up our functions. So to do that, we'll be doing the few checks, whether we can drop it here, so on and so forth. So if we have a start moving, we obviously need a stop moving. So we're going to duplicate that, call it stop moving item. So let's go and open that. And stop moving item is a lot simpler. We want to, because we duplicated it, we have the same stuff. We will change this to back to self only. We will tell this to stop blinking. So stop blinking. And then we just simply need to tell, we don't need this anymore because this only happens if it's open. And we don't need to tell it to move because it's stop. It's stopping right now, because this will be called in the other way. So we don't need an event dispatcher for stopped moving. So we're going to need a function called modify quantity. And it's going to be very similar to what we did in the actual AC inventory, or in the A item, sorry. Modify quantity. And what this does is it takes in an integer for the new quantity. So new quantity right here as an int. And what we want to do is, as usual, we'll get a reference to our value or our structure. We will set members and we'll set quantity. But this time we also need to update our actual text. So we're going to say set get quantity here. Align these two up. And what we want to check is whether this here, if we break it, if quantity is superior to 0, so like that, line these up. If it is inferior to 0, so on false, or if it's equal, we're going to say remove item. So we'll call that right here. So that will go right here and we'll call remove item with it. So we haven't set that up, we'll do that in a second. If it is valid, then we need to tell it to, well, modify the value inside the text box that we made. So we'll just copy this and our value. And we will, actually no, we'll just go to the event begin play because we have it right here. We'll just copy this, put it in modify quantity, put it on true, and we will then also call we'll call item added. Now, or our event dispatcher, sorry. Now the reason we call our event dispatcher here is because the event dispatcher added in a map will be able to just automatically update a value. So even if it is just a simple change in the structure, it won't destroy it, it will just replace it automatically. So that's why we just need added and removed, because those are the only two things you ever need for modifying values in a map. So next we're going to do some actual condition type functions. So the first one we're going to do is a function we'll call isFullyStacked, and this is going to go into a category we'll call conditions. It's going to be pure. It's going to take nothing in, but it's going to return, it's going to return a boolean and it's going to return a remaining. So integer, and this is going to be return value, and the second one is going to be remaining, and this is going to be a boolean. No, I messed it up. That's on outputs. We need that, not on inputs. So return value, and the last one is remaining. Remaining is type integer. And this is like before, we get a reference to our value / structure. We break the pin or split it. We then get max quantity here. And we check whether if it's minus its current quantity, if that is double equal to 0, then we are fully stacked. If not, well, we can just plug the remaining here into our output remaining. It's a very simple function here, but we need it, so we have to do it. The next function we're going to make is another pure cast, so we'll just duplicate this, and it's going to be called isOverlapping. And so what this does is it will take in a location, and it will tell us whether, based on this location, is that location overlapping with this item itself. So call it location, and it's going to be a 2D vector. So let's remove all this. And we don't need the remaining, we just need the if it's true or not. So we'll start off by getting our item structure once again, right here, value, and we're going to break it, and we're going to get its shape. So let's just grab the shape here. And so to do this, we're going to do a for each loop. We're going to check whether this location that we're putting in is a part of this actual thing. So if it fails, meaning we get to the end, then it's not overlapping. On the other hand, if it is, to check that, we need the key and the actual element to be added together. And then we will check whether this location we just brought in is a part of it. So sometimes the vectors can be a bit off, so we put 0.1 here or 0.01 to check whether it's aligned, because we're going to be doing incremental by 1 anyway, but sometimes it can be slightly off, so you need to use either the rounded 2D vector, or if we have an equal here, we can just use the almost equal. So if this succeeds, well, we can return true. Otherwise, we keep trying, and if we still reach the end, well, we didn't succeed, so we ignore it. The final function we need is another very short one, and we can get it once again by duplicating our isFullyStacked, and we're going to call it getCurrentGridLocation. So to do this, what we want is we want to know where we're located. So the output is going to be of type 2D vector. So for this function, what we want to do is we want to get a reference to self, as that's the main child of the grid. So it's the only one we can slot as a grid. So we can then check directly where it is located. Because when we move the item, we're only changing its grid location, not its actual key. So this is a means of getting its current location while moving, instead of getting its origin where it was before. So we get column here. So get column and get row. And we split this. Row goes into Y, column goes into X. We can align these two up, these as well, and move them along. So that does it for the condition type functions. So we can close all three of those right here. So no, not stop moving, but we don't need these anymore either. So now we only have two functions left, if I'm checking this correctly. The first one is called update visual, and the second one is called rotate item. Now, rotate item was one of the functions we needed to add previously in here, which we'll go back and add later. Update visual is actually called right here. So it's a function that will actually align. Mainly what it does is it will move these, the visibility items and the actual text, according to the rotation of the item. So let's go and do that one first. So for this one, what we need to know is first how the size is of the actual item. So to do that, we need to call once again our self. And from our self, we're going to get grid, slot as grid slot. And we're looking this time, instead of for the grid size, we're looking for the span. And we want to get the column and we want to get the row. And we can promote both of these to a variable this time. So L column span, and another one which is going to be L row span. So promote L row span. Let's plug both of these in, align them up, let's move that here. Next, what we want to do is very simple. We get our item structure here. From here, we break it. And what we want to do is we want to rotate our canvas panel, because that's what we go, no, not our canvas panel, sorry. We want to get a reference to item, and we're going to tell our item to get rotated. So set render, I think it is angle. Yes, set render angle to the actual rotation right here. Then hide the unconnected pins. Now, just to make sure before we go any further, I'm going to check for the pivot point here, because we need to make sure this is correct. And I think it should be 0, 0, but I just want to make sure of that. Yeah, so for the image also, we want the pivot to be 0 and 0, because that means when it pivots by 90 degrees, we're moving it exactly on the corner here. So it's much easier to adapt what we need to it. So that's what we're going to do next. When we rotate the item, we need to tell how much of an offset it needs. So we're going to get a reference to our item image again. We're going to set render translation this time. And this is going to set the offset that it needs to adapt when we try and rotate the item. So what I do here is we're going to reroute this, and we're going to actually, I think it is collapse nodes. And we're going to make a collapse node because it's easier to read then. So this is going to be determine offset. So we can go and control click here, because otherwise it will if we double click it, it just replaces it, which we don't want. So determine offset, the values we want is going to be just pretty much a few selects. So it's just going to be mainly long. It's not specifically difficult. So what we want to do for the offset is we're going to do a select here. We'll start with the first one and we'll go through them one by one. So the select we want is we want to get our item structure and we want to check what the rotation is. So we will break it and we will say if the rotation is equal to 90 degrees, we'll do option 1, or in this case, because it's a boolean, we'll take the true. And we'll do the same right here 3 more times, or 2 more times, sorry, on false. Because on true, we'll be doing what the index says. And on the last one, this will simply be 0, 0 because it's no rotation. So if this is true, so we'll give it a bit of space. If this is true, we want to make 2D vector. And what the 2D vector will do is very simple. We want the grid units, we want the L row span, and we will multiply these two together because the row span is just a unit, whereas the grid unit size is how big it is. And we want to plug this into the X. And yes, this is specifically, I'm not making a mistake here, we do want the rows to actually go into the X this time. Because given that it's rotated, it inverts in a sense. So the Y we leave at 0. And obviously if you want, you can test this by simply going and saying, well, hey, we rotate the image by 90 degrees. We only need to offset it by its actual span in row, which is 100. And now it's correctly in it as we want. So that's how we just go through this and test it. But because I know what the values will give, I can just show you like this. So we need a bit more space here. Pull this back along here. We can copy this, or actually we'll just collapse that first. Copy that, plug it into index, and this time we're going to say 180. And on true for 180, we'll once again make a 2D vector, but this time we're going to need a bit more stuff. So actually, sorry, just this part. We're going to need it twice, and we're going to need to replace row span by column span. And this time they're going to be attached accordingly. Row will go into Y, column will go into X, and that'll do it for this one. So let's move it here. Go. And now we can do the last one, which is minus 90 degrees, meaning 270, I think it is. Yeah, I think it, yeah, 270. And so in this case, once again, we can just copy this, place it into true, and on false it's 0, 0, as I mentioned, because no rotation. And this time this gets plugged into Y, but we use the column rotation, the column span, sorry. And with that, we've finished our offsets. Nothing else to do here. We can double click to close this and it will open back up the original one. So next, what we need to do is we need to determine where the actual image will go. Because currently right now, the image will always be sitting right here. So to determine that, what we'll do is we'll have to go through each point and save the largest value and tell, well, hey, the largest value was this. So this is where we want to save this information. So we're going to have to create a local variable we will be calling L corner, and it's going to be of type 2D vector. Compile and save. And so what we do, as usual, get our value. We want our data asset, and we're going to say get shape. Connect the rotation in, and run for a for each loop again. So there we go. Now what we want to do here is we'll do the output first. We want to get our image here. No, sorry, not our image, our text box quantity. And we will say set translation. And the translation we'll be using is we will get our L corner here. We will say times, once again, our grid units here. Line these up. And this time, instead of just plugging this directly, we need to add a little bit of extra offset of 40 by 60. Now this is whatever you want, but it's just that it ends up in the bottom right corner instead of the top left corner. So we can compile and save. Next, we need to do the actual logic right here. So the first thing we want, we'll reroute this so that it has a bit of extra space. And we'll add another one right here. And what we want to do here is actually, sorry, we won't reroute this. We will multiply, and we'll be using the grid again. So we can split this and plug it all in. And what we want to do is we need to actually modify our visibility items here, because we need to tell them to actually move accordingly. So we'll tell them that by saying set render translation again, because that's how we move them in the first place. We'll just update it to the new location based on the rotation that they now have. Next is going to be determining the corner. So we're going to break this item here. And what we'll look for is whether this X is superior or equal to the actual corner, which will break here, so it's easier, split, sorry. And we'll do the same thing for the Y. And if any of these, if these are both true, so we'll use an AND, then we want to update it. Then we want to change what we're currently using as our corner by setting corner to this value. And so with that, we now adapt our actual rotation, our items to the rotation. So if we play now, because we have this called in our begin play here, let's play, our item appears in the bottom right. Or our quantity, sorry, appears in the bottom right. So next we have the rotation, and that's going to be the last step, I think, in the item, and we should be done once we then tell it what to do with rotate and the other functions. So rotate item is rather simple, because quantity, the update visual updates actually everything we need to see. The rotate item just needs to actually update the information. So to do that, we want to get our actual item. We will get render transform angle, which will give us the current rotation. And we're going to add 30 to it, add 90 to it. So to do that, we want to make sure that when we add it, so plus 90 here, we need to know whether we're going above 180. So if this is different from 270, so I want to select here a float. If we're different from 270, then we can just apply this one directly, no questions asked. If it is equal to 270, then we need to tell it to be minus 90 instead. And so this is what we're going to then apply to our value here by saying set members, and we want to set the rotation this time. Sorry, let me just drag that in here. There we go. And so that will do our rotation. Now, after our rotation has been done, we need to tell it to update the visuals so that everything moves accordingly. So let's compile and save, and that will do it for most of the logic here. We just need to now go through our drop item and our other functions that will be dispatching. So drop item, we're going to call our, let's just hide these because we won't need them anymore. We will be calling our dropped right here. So we'll say get self and plug this straight here. This is for drop item. And if we're dropping an item, we're removing it. So we're saying remove drop down as well. And we're also saying remove from parent. So that way this item itself, the item itself will disappear as well. So next we can move on to our remove item, which is going to be similar. We'll call remove here. We will get a reference to self. Plug it in like that. And once again, same thing as before in our drop down, in our drop item. Just copy these two, plug them in here. There we go. And that should be everything. I'm just going to run through them all just to check that I didn't make any mistakes. Hover item, unhover item are correct. Our mouse button should be correct. We did it right at the beginning. So let's go through and check. Everything does seem to be correct. For drop item, we just did it. That's correct as well. Remove item, correct as well. Hover drop down, no problem here. It stops the timer. Unhover starts the timer. Remove drop down removes the drop down if there is one. Is fully stacked, goes through and checks whether it's fully stacked or not, no problem there. Is overlapping, we'll check if we can find the item or the location currently overlapping with this item. Get current grid location gets the current grid location based on the slot for the movement. Start moving calls our moved, starts blinking and makes it no longer hit testable. Stop movement makes the canvas visible again. It removes the visibility, it makes the visibility stop blinking. Modify quantity modifies the quantity, changes the text if it's not 0 and tells it that it's been added because it's been modified. Update visual we just did and it should work normally correctly. We did everything right here. And finally, rotate item, which we just finished, should have no issue either. So that should be all the functions. So that should be everything from the item. Now we can close it for now. I don't think we'll need it again. Inside grid is where we're going to do most of the last bits now. So because currently we don't have all the functions yet for the grid, I don't think. We have most of them, but not all of them yet. So let's go and do that. So in setup grid, we have all our event dispatches now. Let's make it so that we can actually rotate our item. I think that's the first thing we should be doing. So this one, we'll be checking whether we stop moving, so it's place. But right mouse button here should call rotate item. So let's go and try and see if we can now rotate our item. So if we pick up an item now, we can move it. If we right click, it'll actually turn. And if we left click, normally we would place again, but we haven't told it to do that yet. So we'll get to that in a second, but currently we can rotate the item as well. The text stays upright in the bottom, in the right corner. Well, we do have an issue there. So let's try and, let's see what that is. So currently now it's back to normal, it works fine. So it just has an issue there once it's upside down. So I'm gonna go have a quick look at that. It's probably in items where we did the offsets. Okay, so I found what the issue is. It's, I somehow forgot or accidentally missed it. Inside of DA items, we have for the get shape. So if you want, you can access it directly by going in the update visual of our item, clicking on get shape. I forgot to connect the smallest y here is superior to, it was going 0, but we're actually looking for y here. So just like with the x, and so that should fix our issue where if we go upside down, there we go. So now it's aligning correctly. The black flashing is still on top of it. So that will fix that issue. So let's close this and close this. So let's go through all the functions one by one. Can place item we haven't done, and so let's start with that one. So can place item is what will allow us at the end of the day to say whether we can place or not our item in item stop move. No, sorry, in left mouse button down where we tell it to stop. So we need to check whether we can place the item there. So we're going to do just that. So the first thing we need to know is we need to get our moving item. And we need to know where it currently is. So we say get current grid location instead of get key. We then want to get item structure or get value, it's called. And we'll promote this to item location, we'll call it. And we will promote this one to structure. So promote structure. Plug this in here. And the first thing, once again, we want to get our structure here and we want to break it and we want to get the actual shape that we're trying to place. So get shape, plug it in here, and we'll then do a for each loop. So for the shape, what we need to do is we need to check whether, so first what we can do is if this returns completed, then we're done. We succeeded, we can place it. On the other hand, if it didn't, we need to go and look through our item location with our shape and look if we can actually find it. So here we're going to use get rounded, no, not rotated, rounded 2D vector, because otherwise sometimes it doesn't actually find it in our grid state here. So we're going to say find, plug that in. And what we want to do is if we do not find it, meaning there is no slot available, then that's wrong. That means we can't continue. So we just put a branch here and plug this right there. So in that case, if this is true, meaning we didn't find the actual slot, then we return that it's not possible. On the other hand, if that doesn't happen, we reroute this and we plug it in here. That means that we did find the item and that it was true. Now, if it's true, normally, or if it's false, sorry, that means we can actually place it here. So that means we can continue through the loop and then hope that we reach here. On the other hand, if that fails, if we do have an item, we want to check if that item actually is a part of this item or the same type. That way we can immediately add them together. So to do that, we want to get our inventory grid here. We want to say values. And what we'll do with the values is with the function we made for check whether it exists, if it's overlapping, we don't actually need to look for the key directly. We can just immediately go through the values. So the first thing we want is you want to get the value of the item. And with that and our local item structure here, we can check whether the data asset here we need, whether these two are equal. Otherwise there's no point in performing this, and we will just say that it failed. So if these two are equal, right here, so if they're equal, we can keep going. If they're not, we return false. If they are equal, we get a reference to our array element and we say is overlapping. And the value we're looking to overlap is the one we're dragging all the way from over here. Let's just give it a bit of extra space. And there we go. So if this also obviously returns here, we say return false because we didn't manage to find an item that was overlapping. So we branch here and we connect this. If it is overlapping, then we want to check whether the item that we're overlapping, so another reference to this with a reroute all the way at the end here, we can actually just add one here. That way we can just plug it straight there. With this reference, we will check if it is fully stacked, which actually, to be fair, we should make a unpure cast. So go back and open it up and make sure this is unchecked. And back in our grid, we can say now plug it into true. And if it is not fully stacked, so meaning we get false here, we can add something called L quantity extra. And we will promote this on false to the quantity not the quantity remaining. What we want here is we want to get a reference to our local structure here. I think that's what it is. Yeah, so we get a reference to our local structure again, and we're going to get quantity as well here. Or no, we can just get quantity and we'll copy this for the data asset later. We will say the remaining minus the quantity we currently have gives us the extra quantity. And then we're going to need another reference to this here, which we need the data asset from, which will then go into, once again, a reference to this, which will say modify quantity, because we actually can modify the quantity. So we do that right here. We're going to tell it to modify its quantity by a clamp here, because we want to make sure that we don't go above what we can. So we get our max quantity right here, and we put it at the bottom as usual for the max. And for this, what we want is we will be getting our extra quantity here, quantity extra, sorry, and we will be subtracting from the max right here. Sorry, let's just move this along a bit, need a bit more space. With quantity max here, we want to subtract the extra that we have from that maximum, which will then be put into value. Let's just reroute this so it's easier to read. There we go. And so this is how it should look at the end. Just realign that. Sorry. There we go. So this is what it should look like. We're subtracting the extra from the max quantity, because that's how much is left over at the end. So we have that much space to spare, and we can, if it's 0, it will max out anyway, but just to ensure that it does, we leave it clamped. And obviously, if this is, what's it called? If max quantity is negative, so meaning that quantity here is superior to this, let's say there's 5 remaining and we have 7, then we'll have -2. If it's -2, all we have to do is get a reference to our item moving, say modify quantity, and we will modify quantity by the extra times -1, because that's what will be remaining. So obviously this being here, even if it gets a negative value, it will be capped, because it will be saying plus max quantity. So it will know that and it will adapt accordingly, so there won't be any problems there. And then we do one last thing. We check whether in the values, with a for loop again, we want to make sure that these are not hit testable, because in this case we managed to, so we go through the values here and we want to set the visibility back to not hit testable but self only. And we return false. because we cannot place the item because there's something remaining here. Sorry, no, this should probably no, this has an actual boolean here to say whether the quantity remaining, if it is superior to 0, or more like if it is superior or equal to 0, sorry, then we get rid of it. We can tell it that we're done and that we can't place it because there's nothing left to place anymore. So we just tell it to do it that way. So that'll do it for this. This is a bit complicated. I hope it was at least somewhat clear. It's a bit difficult to explain, but pretty much to run through it again, we check all the items that are already placed. We check whether the item we're looking for is the same structure, because if it isn't, we don't care, we can ignore it. If it's overlapping and it's the same structure, then that means we can go ahead and actually stack it on top if we're trying to place it on top instead of just ignoring it. If it's not full stacked, we can actually add the extra quantity to the full stack already there. And if that full stack has anything left, it'll be, or if the old stack that we're holding has anything left, we will add it to the quantity and it will delete itself if it's negative. If the L quantity is superior or equal to 0, that means there's nothing here. That means we have a negative quantity. We then can delete the actual item itself from within here, and here we tell it that we are no longer moving. So we can compile and save. So that's can place done. And so now normally if we start moving the item around, we should be able to place it, although it won't do anything because we haven't told it what to do when we place it. So left mouse button here does item stopped. So let's do item stopped. So for item stopped, what we will call here is we will say removed, because that means that we've succeeded in placing. So we need to tell the moving item that it is now in this new location. So, or at least its old key will be removed properly. And the new one that we just got, so get from moving item, once again, the get current grid location will be its new key. So set key. Not keyboard focus, set key, which will connect these together, and now it has its new location after having erased its old one with the removed right here. Once this is done, we need to make sure that we reset our current location to -99, -99, so that it knows that if we start moving again, we're starting from scratch. Then from our moving item, we need to tell it to stop moving, which will stop the item from blinking and reset its other values. We slot it as a grid here because we need to set it back to its layer 1. So set layer to 1, not 10, but 1. And the next thing we need to do is some functions that we haven't made yet, but we'll do them in a second. First, we can call item added here, which is going to take in from our moving item the value and the actual key. So get key, there we go. Key can go into there, value can go into there. And a few last things is we need to say item moving no longer exists. So we clear it. We want to get our inventory grid, say values, and tell them to be hit testable again, like we did before. So for each, and tell them to be set visibility to self only here. So not hit testable, but only self only. Now to finish this, we need one extra function that's going to be used twice, and that's going to be the actual managing the inventory. So we can just leave this here for now. In a second, we'll come back to it. Let's just test it out and see if we can actually move and place our item. So we can move it, and if we place, it stops blinking. And obviously it's being saved as well, apparently, because we have our event dispatcher for the add that actually saves everything because we set it up before. So we can move it, place it, it's saved between parts. It cannot be placed on the edge here. Even though I'm clicking, it won't go there. Same for here. Here it will place as we want. Now, if we go and pick this up, it's going to fill this one up because it already knows it's there, and it adds the 10 here. But if we try and place it, it won't let us, or at least it shouldn't be doing that normally. So the reason that is because currently right now the inventory grid is still empty because we haven't told it to add the item stat. So that's the next function we're going to be doing right now. which is just a finalized version of add items to grid. So keep the setup here because we're going to be using it in a second. So in the setup grid is where we're going to have one of these. So the first function is going to be add item to grid. It's going to take in a type of UMG item. So let's just get that here, UMG item. And we're going to be using this. The same function is going to be used also for remove, but this time for remove, we don't need the whole thing. So we'll say remove item. Sorry, no, from inventory, actually, we want to call this, not from grid. Item from inventory. And for remove, we want to change this with a 2D vector, which is going to be the key, because the key is all we need to actually remove something. And then we're going to do the same thing for the add item to, or we'll just call it add to state. And this is going to modify our grid state here. So what it needs is it needs the key, which is going to be a 2D vector, and it also needs the actual value. So we're going to give it that as well with the structure. Sorry, the st item, sorry. This is for add, and then we need to do remove, which will, in this case, it needs also both, because this time we need to actually know which we're trying to remove. So this is remove from state. And these four functions are going to be kind of the last thing we need to make everything function together. So let's do them, let's add them where they need to go first, and then we'll go through where they actually need to be used or how they'll be used. So the first one we need is inside of setup grid. We actually need to tell it that we need to add the item to the inventory, otherwise it won't know. So the item we're going to be adding is current item, and this will actually tell it to add it to our inventory grid right here. So we'll know that it can't overlap those and that it needs to hide those other items. So in addition, in item stopped move right here, we want to call that add item to grid as well, because now it's been placed so we can save it. Just move all this a bit to the side here, so a bit of space. Copy the item, place it to UMG item, and align this up. And then we need one last one, which is going to be for the item added. We need to inform it that it's been added to this inventory. So item added right here. And we're going to need to add another one or something else after, but we'll do that in a second. So that does it for item added. Next, we need item remove. So let's go and see where that one goes. So for item moved here, in, I think it's, yeah, item moved right here, we need to tell it that it started moving. So we're going to remove it from the actual inventory. So we're going to call remove item from inventory. We're going to get this, and we're going to say get key. Plug it into here, and we will move that to the side. Now this will remove it from the state and from the inventory itself. That way we know that the item can be placed where it originally was, because it's moving with the player. Then we have a reference obviously in item dropped. So inside of here, we want to get the key. And we'll just do this one first because it needs to be done after. We'll then call ed dropped because we're dropping that specific item. And finally, we call remove item from inventory. Plug it in here. And that will do our actual drop nicely. Now our drop is done as well, even though we weren't trying to do that. And I think that's all we have for the item removed. No, obviously we have it in item removed. Did we do that? We did not. So in item removed, we have the same thing. We get the key and we then say remove from inventory. And then we say item removed. We'll just call the event dispatcher as well while we're at it. Let's go and plug that here. So that does our removed function as well. So let's just close all these. Next up is the add state. So add state, I'm pretty sure is just used inside of our add items inventory. So let's go and actually finally set up these two functions. Let's close everything else. And just do that. So add item from inventory is rather simple. We get the key right here. And we first are going to add it to the actual grid. So we're going to say add, and the function or the value is very simply going to be our actual UMG item that we're bringing in. Then we want to get its key again, so get key, and we want to get value, and that's going to be for our inventory. So add item once again, plug it all in. We want the key and the value in here. And then what we want is we want to add it to the state itself. So we're going to say add to state, and we'll just drag these to right here, like this. May not be the tidiest way of doing it, but it works just fine. Compile and save. And so this will do it for our add item from, no, add item to inventory, not from inventory. That doesn't mean anything. To inventory. So then we'll do our add to state because it's rather simple. We just need to break our value here. We need to say get shape, and we're going to place that shape into our grid state here by doing a for each loop, which we will add our key to, being the location, and we'll then say add, and because we're adding it, this becomes true. Plug that in here, go, line this all up, and that'll do it for add to state. We can copy this for the remove from state because it's exactly the same. We just need to change the check to unchecked, and I'm just going to make sure that's true, that I'm not making that up. So one thing we do need to do as well, because sometimes this can happen, we want to check if this is valid. If this is valid before actually doing this. So the last thing we need is remove from inventory, which we have right here. It's going to do a sequence because this needs to be done in a few steps. We want to remove our item only at the end. So we will get our key because we're going to need to go through it first before we actually delete anything. So if we want to remove state, which is what we do here first, we need to actually have the item existing, otherwise it doesn't work. So then inventory grid, we can also say remove with the key, which we get right here, plug that in. And to finish, we get our key here, we get our inventory, and we find our key, and we plug that into the value. And that's the reason this has to be done in this specific order, even though it doesn't change much. You have to do it like this first, because otherwise we can't find what we don't have. So normally now, if we go and move items, there's nothing wrong. If we right click on it and drop, it will appear in front. We can pick up the other one first, appears here, pick up the second one. Currently we can't add anything because, well, it's already full. So we'll keep our item in hand, it won't change anything. Close and open it, it's still there. We can't actually rotate it here because there's no space to actually place it, so that won't work. As you can see, the rotation remains the same. Normally, the dark part is at the bottom. It's at the top here because it's rotated 180 degrees. Move this, same thing, stay there as well. And now we can just rotate it there. It all works the same. What we can do also is we'll change one of these items just to test as well, that we cannot place it on top of one another. Seem to have an issue there. So let's try and see what's wrong. Okay, so the reason it had that weird shape again is because once again in the actual here in the shape we fixed it, but the same problem with the max Y exists in the max size because apparently I forgot that as well. So we plugged that in, and now normally if we go and pick up J, it appears correctly as it should. If we move this item here, we can't place it, but if we place it here, it works, it slots right in, no problem whatsoever. You can try the same thing if we rotate it. It'll fit right here as well, no problem. We can still click on that one or that one, no issue. If we do it the other way around, same thing as well, no problem. So that does it. I hope you managed to follow this because it is kind of long, I'm not gonna lie, and it is very, I wouldn't say difficult, but tedious, and the tutorial is extremely long. I've been at this for about 4.5 hours at this point. I don't know how long it's going to be in the editing, but I hope you enjoyed it. I hope it taught you what you wanted to do and that you managed to reach the end and accomplish what you were aiming to do with this tutorial. Thank you for watching, and I will see you in the next video. Goodbye.